Hello there, and welcome to Just About Earth, a place where curiosity settles in quietly, and the science of our home planet takes a slower, gentler path. Wherever you are listening from right now, whether the light outside your window is fading or only just beginning to rise, I am glad you're here. This space is meant for easing the mind rather than racing it, for asking questions that do not demand quick answers, and for letting ideas unfold at their own pace. So take a moment to get comfortable, adjust your headphones if you need to, and let your thoughts loosen their grip just a little. Tonight, we are going to explore a thought that may sound strange at first, but the longer you sit with it, the more quietly familiar it begins to feel. What if Earth controls everything? Not in a dramatic science fiction sense, not as a conscious ruler issuing commands or pulling levers behind the scenes, but as something older, steadier, and far less concerned with being noticed. What if the planet beneath us is not simply a setting for life, but the system that quietly shapes how life unfolds, moves, grows, pauses, and changes? What if Earth does not respond to us nearly as much as we respond to it, often without realizing we're doing so? Before we go any further, let me gently ask you something. Where are you listening from right now? Are you in a city where the ground is hidden beneath concrete and lights glow late into the night? Or are you somewhere quieter, where the sounds of wind, insects, or distant water still find their way inside? And what time is it for you in this moment? Not just the number on a screen or a clock, but the feeling of the hour. Is it a time when the day is winding down, or one where it has barely begun to stretch its limbs? There is something fitting about asking these questions as we begin, because even without noticing, the answers are already shaped by Earth itself. If you find this kind of exploration calming, or if you enjoy drifting through ideas like these as you rest or prepare for sleep, you might consider liking the video or subscribing to Just About Earth. It helps this quiet corner reach others who may be looking for a slower way to connect with science and the world around them. There is no rush, though. You're welcome to simply listen and let the words pass through at their own speed. Now, let us ease into the idea itself. When most of us think about Earth, we imagine a planet floating in space, a large sphere of rock and water wrapped in clouds. We learn its size, its distance from the sun, its age measured in billions of years. We are taught that it orbits, rotates, and follows physical laws just like everything else. All of that is true, and yet it only tells part of the story. Because while Earth follows the laws of physics, it also sets the conditions under which nearly every experience of life takes place. Consider something as ordinary as standing still. You're not floating away. You're not drifting sideways or upward. You remain gently pressed against the ground, held in place without effort. Gravity is doing that, of course, but gravity as you experience it is shaped by Earth's mass, its size and its structure. The way your body rests, the way your muscles work, the way your heart pumps blood upward against resistance, all of that has quietly evolved in response to this constant pull. From the outside, it may seem like you are choosing to stand, walk, or sit. From another perspective, your body is simply cooperating with a planetary force that has always been there. Now think about time, not as an abstract concept, but as something you feel. The length of a day, the rhythm of a light and darkness, the regular return of morning and evening. Earth rotation sets this pattern, and every living thing on the planet has adapted to it in some way. Long before clocks existed, before language even had words for hours or minutes, life was already syncing itself to the turning of the planet. Plants open and close, animals rest and wake. Human bodies release hormones on schedules that mirror the rising and setting of the sun. Even now, with artificial light and digital screens, that deeper rhythm remains difficult to escape. It is easy to believe that modern life has freed us from Earth's influence. We heat our homes, cool our buildings, travel across continents in hours, and communicate instantly across the globe. From one angle, it looks like control. From another, it looks more like adaptation. We adjust our behaviour to stay comfortable within Earth's systems rather than stepping outside them. Airplanes still rely on air density and weather patterns. Power grids depend on temperature and seasonal demand. Food production remains tied to soil, water and climate, no matter how advanced the tools become. When you begin to notice these connections, the idea that Earth controls everything starts to feel less like a bold claim and more like a quiet observation. Control does not have to mean intention. It does not have to involve decision-making or awareness. Control can simply be the act of setting boundaries so fundamental that everything else must operate within them. Earth sets the boundaries of gravity, atmosphere, chemistry, and energy flow. Within those boundaries, life experiments endlessly, but it never truly steps outside them. Think about breathing. Every breath you take depends on the composition of Earth's atmosphere. The precise balance of oxygen and nitrogen is not accidental. It is the result of billions of years of geological activity, volcanic gases, biological processes, and feedback loops that gradually shape the air into something breathable. If that balance shifted even slightly, complex life would struggle. You do not choose the chemistry of the air each time you inhale. You simply live within the conditions Earth provides. Water offers another example. It covers most of the planet, cycles endlessly between ocean, sky, and land, and behaves in ways that are unusually friendly to life. It expands when it freezes, allowing ice to float and protect liquid water below. It absorbs heat efficiently, stabilizing temperatures. It dissolves nutrients and transports them through ecosystems and bodies alike. These properties are not directed at humans specifically, yet every civilization, culture, and organism has been shaped by them. Where water flows, life follows. Where it disappears, life retreats or adapts. Even the land beneath your feet carries quiet influence. The thickness of Earth's crust, the movement of tectonic plates, and the slow recycling of minerals determine where mountains rise, where rivers form, and where fertile soil accumulates. Cities tend to grow where resources are accessible. Trade routes follow coastlines, valleys, and passes carved long before humans arrived. Conflicts often trace back to land, water, and climate. It is tempting to see these events as purely human decisions, but beneath them lies a physical landscape that nudges choices in certain directions while making others far more difficult. None of this suggests that Earth is watching us or reacting to our individual actions. The control, if that is the right word, is impersonal. It is the kind of control exercised by rules that do not change because someone is unhappy with them. Gravity does not negotiate. Seasons do not pause for convenience. When conditions shift, life responds, not the other way around. Species migrate, adapt, or disappear. Civilizations adjust their practices or face consequences. The planet does not hurry, and it does not apologize. At the same time, this influence is not hostile. Earth is not an adversary. The same systems that limit us also support us. The same gravity that keeps us grounded allows oceans to stay in place and atmospheres to remain wrapped around planets instead of drifting into space. The same tectonic activity that causes earthquakes also recycles nutrients and regulates long-term climate. Control, in this sense, is not punishment or reward. It is simply structure. As you sit with this idea, you might notice how it reframes the way we think about agency. Humans often describe themselves as shaping the world, changing it, mastering it. There is truth there. We alter landscapes, redirect rivers, and influence climate in measurable ways. And yet, every one of those actions happens within limits set by Earth itself. We do not decide how strong gravity is. We do not rewrite the basic chemistry of water. We do not choose the speed at which the planet rotates. Our influence is real, but it is layered on top of much older framework. This is not meant to diminish human creativity or responsibility. In fact, it quietly emphasizes it. When you recognize that Earth sets the conditions, human choices become more clearly about how we operate within them. We can cooperate with planetary systems or strain against them. We can pay attention to feedback or ignore it. The planet will continue either way. The outcomes, however, will differ. As these thoughts settle in, notice how they do not demand urgency. Earth operates on timescales that stretch far beyond individual lifetimes. Mountains rise and erode, oceans open and close, climates shift gradually, then sometimes abruptly. Against that backdrop, a single evening, a single breath, or a single question becomes small but not insignificant. You're part of the system simply by being here, supported by forces you did not design and could not replace. And as we continue, we will gently look at some of those forces more closely, not to overwhelm or impress, but to understand how quietly pervasive they are. Because the more you notice them, the more it becomes clear that control does not always announce itself. Sometimes it simply holds everything in place, moment after moment, without asking to be thanked or even seen. At first, the idea sounds a little ridiculous, almost playful in a way that makes you want to smile and move on. The ground is listening. We're used to listening being something that requires ears, attention, intent. We associate it with minds, with awareness, with something leaning in and actively trying to understand. Rocks do not do that. Soil does not perk up when you speak. Pavement does not pause to take in your footsteps. And yet, if you set aside the literal meaning for a moment and think instead about response rather than awareness, the idea begins to shift into something more interesting. Because the ground responds, constantly, quietly, without commentary. Every weight placed upon it, every movement across its surface, every drop of water that falls, every structure that rises, none of it happens in isolation. The planet registers it all, not in thought or memory as we experience them, but through pressure, vibration, chemistry, heat, and motion. And those responses shape what happens next. Take something simple, like standing still. Your body presses downward with a force determined by your mass and Earth's gravity. The ground beneath you compresses slightly, even if you cannot feel it. If you are on soft soil, it yields more. On rock, almost imperceptibly. On sand, grains rearrange themselves, distributing your weight outward. The planet does not notice you as an individual, but it does respond to the force you introduce. Multiply that by billions of people, by cities, by vehicles, by towers, and suddenly the surface of Earth is under constant negotiation with what lives upon it. This is not metaphorical. In some cities, the sheer weight of buildings causes the ground to sink over time. In others, groundwater extraction changes pressure deep underground, leading to slow subsidence that reshapes coastlines. These are not reactions fueled by intention, but they are responses all the same. Something happens, the system adjusts. Now consider sound. When you speak, when traffic moves, when machines operate, vibrations travel through air and into the ground. Seismologists can detect footsteps, trains, even storms using sensitive instruments. Earth does not hear in the way animals do, but it transmits and transforms vibrations constantly. The planet is never still. Even when it feels quiet, the ground hums with motion, from oceans pounding distant shores, from wind moving across landscapes, from tectonic plates shifting at speeds too slow to notice, but never truly stopping. If you sit somewhere quiet and place your hand on the ground, you are touching a surface that is carrying information from all over the planet. Pressure waves from earthquakes on the other side of the world pass through rock beneath you. Temperature gradients move heat upward and downward. Water seeps, freezes, melts, and flows. The ground does not store these things as thoughts, but it integrates them into its ongoing physical state, and that state determines what can happen next. This is where the idea of listening becomes less whimsical and more grounded. To listen, in the broadest sense, is to be affected by input, to change in response to what is introduced. By that definition, Earth listens continuously. It cannot choose to ignore. It cannot filter out inconvenient signals. Everything that happens on its surface becomes part of the system it must accommodate. Think about footprints. A footprint seems temporary, something erased by wind or rain. But even when the visible mark disappears, the ground has still been altered. Soil structure shifts, microorganisms are disturbed, moisture distribution changes slightly. Over time, countless small disturbances like this influence erosion patterns, vegetation growth and surface stability. No single step matters much. Together they matter a great deal. This responsiveness is especially clear when we look at how Earth reacts to water. Rain does not simply fall and vanish. It strikes the surface, transferring energy. It infiltrates soil at rates determined by texture and composition. Excess water runs off, carving channels that deepen over time. Rivers do not decide where to flow. They respond to gravity, rock hardness, sediment load, and previous pathways. Each flood reshapes the land slightly, reinforcing some routes and abandoning others. The ground takes in the signal of water again and again, adjusting its form in response. Plants participate in this exchange as well. Roots push through soil, applying pressure, releasing chemicals, and altering moisture levels. Over years, entire ecosystems can change the structure of the ground beneath them. Forests stabilize soil. Grasslands build deep root networks that hold earth in place. Wetlands trap sediment and buffer floods. These are not acts of control by plants alone. They are feedback loops between life and land. The ground responds to what grows on it, and that response shapes what can grow next. When humans enter the picture, the scale of disturbance increases dramatically. Roads compact soil. Agriculture turns layered ecosystems into managed surfaces. Mining removes entire sections of Earth's crust, redistributing materials across continents. From a human perspective, these actions feel deliberate and directed. From Earth's perspective, they are forces to be absorbed and balanced. Remove mass here, pressure redistributes there. Seal surfaces, water finds new routes. Heat cities, air circulation changes. This is not to say the planet pushes back in anger. That language implies emotion, which is not what is happening. The response is mechanical, chemical, physical. If you place a heavy object on a cushion, the cushion deforms. It does not resent the weight. It simply changes shape. Earth does the same, only on scales that are sometimes slow enough to escape notice, and sometimes sudden enough to feel dramatic. Earthquakes offer a clear example. Tectonic plates are always moving, driven by heat and gravity deep within the planet. Stress builds where plates meet, resisted by friction. When that resistance is overcome, energy is released suddenly. Buildings shake, ground cracks. From our perspective, it feels like an event, an interruption. From the planet's perspective, it is a release of accumulated strain, a continuation of processes that never stopped. The ground responds to forces acting within it, and we happen to live on the surface where those responses become noticeable. The idea that the ground is listening also becomes compelling when we consider time. Earth integrates inputs over vast spans. A single storm may not change a coastline, but thousands will. A single building may not alter a city's elevation, but millions will. A single emission may not warm the planet, but trillions will. The ground does not react immediately to everything. Sometimes it stores energy, heat, or stress until thresholds are crossed. At that point, change can feel abrupt, even though it was prepared over long periods. This long memory is not conscious, but it is real. Ice cores preserve records of atmospheric composition, stretching back hundreds of thousands of years. Sediment layers record floods, droughts, volcanic eruptions, and human activity. Tree rings reflect temperature and rainfall year by year. The planet carries the physical imprint of what has happened upon it, whether anyone intended to leave a mark or not. In that sense, Earth does not just listen. It remembers, in a way that can be read by those who know how to look. There is something humbling about realizing how little effort it takes to leave a trace. Even if you never build anything, never travel far, never intentionally alter the landscape, your presence still interacts with the planet. You generate heat. You exhale carbon dioxide. You consume resources that must be extracted, transported, and transformed. Each of these actions becomes part of Earth's ongoing adjustment process. Not because you are important individually, but because systems respond to totals, not intentions. At the same time, this responsiveness creates a strange sense of intimacy. You're not separate from the ground beneath you. You're in constant exchange with it. Your bones contain minerals that once cycled through ancient rocks. The water in your body has moved through clouds, rivers, oceans, and living things countless times. The oxygen you breathe was released by plants responding to sunlight and soil conditions shaped by geology. Listening, in this context, is mutual. You respond to Earth as much as it responds to you. This idea also helps explain why certain changes feel uncomfortable even before we fully understand them. When landscapes are altered rapidly, when natural rhythms are disrupted, when surfaces are sealed and flows redirected, the system adjusts in ways that can feel unpredictable. Floods become more severe. Heat lingers longer. Soil loses fertility. These are not punishments. They are consequences of altered inputs. Earth continues listening, continues responding, even if the signals have changed faster than before. There is a tendency to frame these responses as warnings, as if the planet were sending messages meant to be interpreted. That can be useful metaphorically, but it can also be misleading. Earth does not warn. It does not threaten. It reacts according to physics. If you understand the system, the outcomes make sense. If you ignore the system, the outcomes feel surprising. The listening is always happening either way. As you rest with this thought, you might notice how it changes the feeling of being on the planet. The ground beneath you is not inert. It is not a passive stage. It is active, dynamic, constantly balancing forces introduced from within and above. That does not mean it is fragile in the way living things are fragile. Earth has endured impacts, eruptions, ice ages, and mass extinctions. It will continue. What changes is what can exist comfortably on its surface at any given time. Understanding that Earth listens in this physical sense invites a quieter form of awareness. Not vigilance, not anxiety, just attention. When systems respond to inputs, knowing the nature of those inputs matters. When you realize that nothing happens in isolation, even small actions gain context. Not moral weight necessarily, but physical relevance. The ground does not judge, it adjusts. It is easy to forget about gravity precisely because it never leaves us. It does not arrive with sound or light. It does not announce itself when it begins or ends, because for us, it never ends. From the moment you are born, gravity is already there, steady and patient, shaping how your body learns to move, how your balance develops, how effort feels, and how rest settles in. You do not notice it in the same way you notice weather or noise. You notice it only when it is challenged, when you trip, when you lift something heavy, or when for a brief moment you imagine what it would feel like if it were gone. Gravity is often described as a force, but in daily life it behaves more like a quiet agreement between you and the planet. Earth pulls, and you respond without thinking. You lean slightly forward when you walk, you shift your weight when you stand, you brace yourself instinctively when you expect impact. None of this requires conscious calculation. Your nervous system learned gravity before it learned language. Long before you could name the planet, your body had already accepted its pull as a given. From a distance, gravity looks simple. Objects fall downward. Planets orbit stars. Moons circle planets. But up close, gravity becomes something more intimate. It decides how tall trees can grow before they collapse under their own weight. It determines how blood circulates in your body and why your heart must work a little harder to send blood upward to your brain. It shapes the structure of bones, the density of muscles, and the way joints are designed. Every organism on Earth is built with gravity in mind, even if it never thinks about it. When people imagine control, they often imagine something active, something intervening. Gravity controls without intervention. It does not push objects down in bursts or pulses. It simply exists as a constant curvature in space, a steady influence that everything else must navigate. You can resist it briefly. You can jump, climb, or fly. But every jump ends. Every climb requires effort. Every flight relies on engines working against gravity's pull. Even when you leave the ground, gravity remains part of the equation, waiting to reclaim you. What makes gravity especially powerful as a guiding force is its consistency. Other influences vary. Weather changes, temperatures fluctuate, resources shift. Gravity does not. It remains remarkably stable over human timescales. This stability allows complex systems to form. Oceans settle into basins. Atmospheres remain bound to planets instead of drifting away. Mountains rise until gravity and erosion balance their growth. Without this quiet persistence, Earth would be a very different place, and life as we know it would struggle to exist at all. Gravity also does something subtle but profound. It creates a sense of direction. Down is not just a word. It is a shared experience. Every culture understands it intuitively. Languages develop metaphors around it. Things fall apart. Spirits sink. Burdens weigh heavily. These expressions exist because gravity gives physical meaning to direction and effort. Without gravity, the idea of down would lose its anchor, and with it, many of the ways we describe the world. Consider water again, not as an abstract substance, but as something that moves. Gravity gives water its pathways. Rain falls downward. Rivers flow from higher ground to lower ground. Groundwater seeps through layers of rock under pressure created by gravity. Without it, water would not collect into oceans or lakes. It would disperse unpredictably. The entire water cycle depends on gravity acting consistently over time. Clouds form, rain falls, rivers return water to the sea. This loop feels natural because gravity makes it so. The same is true for air. Earth's atmosphere stays close because gravity holds it. Gases that would otherwise drift into space remain available for breathing, weather, and climate. The thickness of the atmosphere, its pressure at the surface, and the way sound travels through it are all consequences of gravity's pull. When you take a breath, you are participating in a system made possible by Earth's mass holding invisible particles close. Gravity also shapes time in ways that are less intuitive. The stronger the gravitational field, the slower time passes relative to weaker fields. This effect is subtle at Earth's surface, but it is real and measurable. Clocks placed at different altitudes tick at slightly different rates. Satellites orbiting above the planet experience time differently than clocks on the ground. These differences are small, but they must be accounted for in modern navigation systems. Even here, gravity quietly influences systems we rely on daily without drawing attention to itself. What makes gravity feel like an invisible hand is that it does not discriminate. It pulls on everything equally, regardless of purpose or intention. A falling leaf and a falling stone are both guided by gravity, even though their paths differ because of air resistance and shape. Gravity does not decide which objects matter more. It simply applies itself universally. This impartiality is part of what makes it such a powerful organizing principle. Systems can be built around it because it behaves predictably. Human structures reflect this constant negotiation. Buildings are designed to transfer weight downward into the ground. Bridges distribute load so gravity does not concentrate stress in one place. Vehicles are engineered to remain stable under acceleration and braking, both of which involve working with gravity rather than ignoring it. Even furniture is shaped by gravity, with flat surfaces designed to support objects that would otherwise fall. In space, The absence of familiar gravity reveals just how deeply it shapes us. Astronauts experience muscle loss and bone density reduction because their bodies no longer receive the constant signal to maintain structure against gravity. Fluids redistribute. Orientation becomes ambiguous. Tasks that feel trivial on Earth require careful planning. This is not because space is hostile, but because Earth's gravity has trained our bodies to expect certain conditions. Remove that influence, and the system must adapt. Gravity also influences how we perceive effort and rest. Lying down feels restful partly because it reduces the work required to support your body against gravity. Sitting feels easier than standing for the same reason. When you're tired, gravity feels heavier, not because it has changed, but because your capacity to counteract it has diminished. In this way, gravity becomes part of your internal experience, tied to fatigue, comfort, and strain. Even sleep is shaped by gravity. The positions we find comfortable, the way breathing changes when lying down, the pressure points that develop, all involve gravity interacting with soft tissue and skeletal structure. The design of beds, pillows, and sleeping surfaces reflects an ongoing attempt to cooperate with gravity rather than fight it. Comfort emerges not from eliminating gravity, but from distributing its effects more evenly. On larger scales, gravity governs the shape of the planet itself. Earth is roughly spherical because gravity pulls matter toward the center, smoothing out large irregularities over time. Mountains rise, but gravity ensures they cannot grow indefinitely. Erosion, landslides, and weathering are all gravity-assisted processes that gradually redistribute material. Even tectonic plates move in part because gravity acts on dense, sinking material deep within the mantle. This slow reshaping gives Earth a kind of long-term stability. Changes happen, but they follow patterns. Coastlines retreat and advance. River valleys deepen. Plains accumulate sediment. These processes do not rush, but they do not stop. Gravity provides the constant background against which all of this unfolds. It is not dramatic in isolation, but over millions of years it becomes transformative. There is also something psychologically grounding about gravity, even if we rarely articulate it. Knowing that objects fall, that surfaces support us, that movement has predictable consequences, creates a sense of reliability. When gravity behaves as expected, the world feels stable. When it is disrupted, as in falls or accidents, the disruption feels jarring precisely because it breaks that expectation. Gravity is woven into our sense of safety. Thinking about gravity as a form of control does not mean imagining Earth as exerting dominance. It means recognizing that some influences are so fundamental they shape possibility itself. You cannot choose to opt out of gravity. You can only work within its rules. That constraint paradoxically enables complexity. Because gravity is reliable, life can build on it. Structures can persist. Cycles can repeat. Gravity begins to feel less like a force acting on you, and more like a condition you exist within. It is not something you experience separately from the world. It is part of how the world holds together. And because it is always present, it often escapes attention, doing its work quietly while other phenomena take center stage. There is a rhythm that runs beneath nearly every experience of life on this planet, a steady pattern that does not hurry and does not pause, whether or not anyone is paying attention. It is so familiar that it often fades into the background, becoming the assumed shape of existence rather than something actively noticed. Morning follows night, light gives way to darkness, warmth rises and falls, tides come in and slip back again. This rhythm does not belong to clocks or calendars. Those are only tools we invented to keep track of something that was already there long before we arrived. Earth sets this rhythm through motion. The planet turns, it travels, it tilts. These movements are not dramatic in the way storms or earthquakes can be, but they are relentless. Earth rotates once roughly every 24 hours. It orbits the Sun once every year. Its axis tilts just enough to create seasons rather than uniformity. None of this was arranged for comfort or convenience, yet all of it quietly dictates the conditions under which life unfolds. Think about the simple fact of day and night. This alternating pattern shapes behaviour so deeply that it feels almost inseparable from being alive. Waking and sleeping, activity and rest, alertness and fatigue, all tend to follow the cycle of light and darkness. Even people who work through the night or live under artificial lighting are still affected by this rhythm. Their bodies carry expectations shaped by millions of years of evolution under a rotating sky. When those expectations are disrupted, discomfort often follows. The sun does not rise and set because it moves around us. Earth turns toward and away from it. This turning creates a predictable sequence of light exposure that organisms have learned to anticipate. Plants lean toward light during the day and adjust their internal chemistry at night. Animals forage, hunt, hide, and rest according to these shifts. Human bodies release hormones, adjust temperature, and alter metabolism in response to the presence or absence of daylight. Even if you ignore the clock, your body knows roughly where it is in the cycle. This internal timing is not learned from culture, it is inherited. Newborns arrive with biological clocks that begin syncing to the environment almost immediately. Over time, these clocks become aligned with local light patterns. Travel across time zones disrupts this alignment, creating the strange disorientation known as jet lag. The discomfort is not caused by distance, but by rhythm being suddenly out of step with expectation. Earth continues turning at the same rate, but your internal timing lags behind, trying to catch up. Beyond the daily cycle lies a slower rhythm, one that unfolds over months rather than hours. Seasons emerge from Earth's axial tilt as it travels around the Sun. This tilt means different parts of the planet receive varying amounts of sunlight throughout the year. When one hemisphere tilts toward the Sun, days lengthen and temperatures rise. When it tilts away, days shorten and cold settles in. This gradual shift shapes ecosystems, agriculture, migration patterns, and cultural traditions. Spring is not simply a time on a calendar. It is a response to increasing daylight and warming soil. Plants begin to grow because chemical processes accelerate under these conditions. Animals reproduce when food becomes more abundant. Humans plan planting, harvesting, festivals, and routines around these predictable changes. Even in modern societies with global supply chains and controlled environments, seasonal rhythms still influence mood, energy levels, and behavior. There is a reason some people feel heavier in winter and lighter in summer, even if their daily routine remains unchanged. Earth's rhythm extends into the oceans as well. Tides rise and fall in response to the gravitational pull of the moon and the sun, interacting with Earth's rotation. Coastal ecosystems depend on this regular movement of water. Tidal zones are shaped by alternating exposure and submersion. Marine organisms time feeding and reproduction to these cycles. Human coastal communities have historically organised fishing, trade, and travel around tidal schedules. The sea does not keep time by watches, but by gravity and motion. These rhythms interact with one another, layering cycles upon cycles. Daily light changes interact with seasonal shifts. Tides intersect with weather patterns. Temperature fluctuations influence wind, precipitation, and ocean currents. The result is not chaos, but a complex pattern that repeats with variation. This predictability allows life to plan, adapt, and specialize. When rhythms are stable, systems become finely tuned. When rhythms shift, those systems must adjust. The idea that Earth sets the rhythm becomes clearer when you imagine its absence. Without rotation, there would be no day and night. One side of the planet would face constant sunlight, the other permanent darkness. Temperature extremes would make much of the surface inhospitable. Without axial tilt, there would be little seasonal variation. flattening the diversity of climates that support different forms of life. Without orbital motion, energy input from the sun would be static or absent. Life as we know it depends on change as much as it depends on stability. Rhythm also governs less obvious processes. Soil formation follows seasonal cycles of freezing and thawing, wetting and drying. Nutrient availability fluctuates with plant growth and decay. Insects emerge at specific times based on temperature thresholds. Predators time their activity to prey behavior. These patterns interlock, creating webs of dependence that rely on timing as much as location. A shift in rhythm can ripple through an ecosystem in unexpected ways. Human societies have always been shaped by these cycles, even when they believe they're acting independently. Early calendars were attempts to map celestial rhythms onto daily life. Agriculture required careful attention to seasonal timing. Religious observances often aligned with solstices, equinoxes, or harvests. Even now, work schedules, school years, and holidays reflect inherited patterns shaped by Earth's motion. We may no longer track the sun's position by eye, but we still live within its influence. Modern technology sometimes gives the impression that rhythm has been conquered. Artificial lighting extends the day. Climate control smooths temperature extremes. Global trade delivers seasonal foods year-round. Yet the underlying cycles persist. Energy demand rises and falls with daylight and temperature. Health outcomes vary seasonally. Power grids strain during heat waves and cold snaps. Technology mitigates but does not eliminate Earth's rhythms. It layers additional patterns on top of them. Disruption of rhythm often reveals its importance. Shift work, irregular sleep schedules, and constant exposure to artificial light can lead to fatigue, mood changes, and health issues. These effects are not moral judgments or signs of weakness. They are physiological responses to misaligned timing. The body expects certain cues at certain times because Earth has provided them reliably for so long. When those cues disappear or arrive out of order, confusion follows. This dependence on rhythm extends into the brain. Cognitive performance varies with time of day. Memory, attention, and reaction speed fluctuate according to internal clocks synchronized with external light. Emotional regulation is influenced by sleep quality and timing. Even creativity can feel easier at certain hours. These variations are not random. They're expressions of biology shaped by planetary motion. It is tempting to think of rhythm as something gentle, even comforting. Often it is. Predictable cycles provide structure. They allow rest to follow effort, renewal to follow depletion. But rhythm can also be demanding. Seasons bring scarcity as well as abundance. Night brings danger as well as rest. Tides can isolate or expose. Earth's rhythm does not prioritize ease. It prioritizes balance over time. Organisms that align with it tend to persist. Those that do not must adapt or fade. This does not mean rhythm is rigid. Earth's cycles are stable but not fixed in every detail. Day length varies by latitude. Seasons differ in intensity depending on geography. Ocean currents shift. Climate patterns oscillate. Within the broad framework of planetary motion, there is room for variation. Life exploits this variation, diversifying to fill niches created by subtle differences in timing and intensity. Understanding Earth as the setter of rhythm reframes the idea of control. Control here does not mean enforcement. It means establishing the tempo within which everything else must move. Life can improvise, but it cannot ignore the beat entirely. When organisms fall out of sync, consequences follow, not because the planet punishes them, but because timing matters for survival. As you reflect on this, you might notice how rhythm shapes your own experience right now. The time of day influences your alertness. The season affects the light entering the room. Even your breathing follows a rhythm that settles when you relax. None of this requires conscious direction. It happens because Earth's movements have been translated into biological patterns over countless generations. This rhythm is not something you need to resist or surrender to completely. It simply exists, and you move within it whether you notice or not. Becoming aware of it does not change its pace, but it can change how you relate to it. Instead of feeling rushed or constrained by time, you might begin to see yourself as participating in cycles far older and larger than individual schedules. Weather is often spoken about as if it were an order being given. Storms arrive, heat waves strike, cold fronts move in. The language suggests intention, almost authority, as though the sky has decided something and the ground below must comply. But when you look more closely, weather is not issuing commands. It is whispering responses. It is Earth adjusting continuously, moment by moment, to imbalances in energy, moisture and motion. Nothing about it is sudden from the planet's point of view, even when it feels abrupt from ours. At its core, weather exists because Earth receives energy unevenly. Sunlight does not strike every part of the planet with the same intensity at the same time. The equator receives more direct sunlight than the poles. Land heats and cools faster than water. Mountains redirect air currents. Oceans store heat and release it slowly. These differences create gradients, and gradients create movement. Air flows from regions of higher pressure to lower pressure. Warm air rises. Cool air sinks. Moisture condenses and falls. Weather is simply the visible result of Earth redistributing energy in search of balance. This redistribution never stops. Even on the calmest day, air is moving, heat is shifting. Water is evaporating somewhere and condensing elsewhere. We call some of these movements breezes and others storms, but the difference is mostly one of scale and speed. The processes are the same. Weather does not wake up one morning and decide to be dramatic. It follows physical rules with no awareness of inconvenience or expectation. Because weather is a response rather than a directive, it often feels oddly conversational. Clouds build, hesitate, then disperse. Rain falls lightly for hours or suddenly in torrents. Winds change direction, pause, and resume. These shifts can feel personal when they interrupt plans or alter moods, but they are not aimed at anyone. They are the planet speaking to itself through movement, adjusting temperature and moisture until conditions shift again. Think about a single cloud. It forms when warm, moist air rises and cools, allowing water vapor to condense into tiny droplets. Those droplets scatter light, becoming visible. The cloud persists only as long as conditions allow. If the air warms, it dissolves. If droplets grow heavy enough, they fall as rain. The cloud does not hold together out of purpose. It exists because energy and moisture are briefly aligned. Weather is full of these temporary structures, appearing and disappearing as conditions fluctuate. Rain is another example of weather as response. When water evaporates from oceans, lakes and soil, it carries heat upward. When that vapor condenses into liquid, heat is released. Rain cools the air and the surface it falls on. It feeds rivers and groundwater, replenishing systems that will later evaporate water again. Rain is not a gift or a punishment. It is a step in an ongoing exchange, one part of a cycle that balances heat and moisture across the planet. Wind, too, often feels aggressive, but it is simply air moving in response to pressure differences. Strong winds occur where those differences are steep, often near storms or temperature boundaries. Gentle breezes arise where gradients are mild. Wind does not seek to knock things over. It transfers energy, redistributes heat, and moves moisture. When it uproots trees or erodes soil, it is not acting out of forceful intent. It is following the same rules it always follows, interacting with structures placed in its path. Weather patterns become more complex when Earth's rotation enters the picture. As the planet spins, moving air is deflected, creating swirling systems like cyclones and trade winds. These patterns are stable enough to be studied and mapped, yet flexible enough to vary from year to year. They form highways in the atmosphere. guiding storms, shaping climates, and influencing where rain tends to fall or fail to fall. Climate is often confused with weather, but they are different expressions of the same processes. Weather is what happens in the short term. Climate is the long-term pattern of those happenings. Climate describes averages, ranges, and tendencies. It reflects how Earth's energy balance plays out over decades and centuries. When climate shifts, it is not because Earth has changed its mind. It is because underlying conditions have altered, changing how energy and moisture are redistributed. From the perspective of ecosystems, weather is not an interruption. It is part of the environment's ongoing conversation with itself. Plants are adapted to withstand wind, rain, heat, and cold within certain ranges. Animals adjust behavior based on weather cues, seeking shelter, migrating, or altering activity patterns. Extreme weather becomes dangerous when it exceeds what systems have adapted to handle, not because it is abnormal for Earth, but because it pushes beyond biological tolerance. Human experience often frames weather as something to be managed or avoided. Forecasts warn of incoming systems. Infrastructure is designed to withstand expected conditions. When weather behaves outside those expectations, disruption follows. This can create the impression that weather is misbehaving, but in reality it is simply operating within a system that has changed. As land use, atmospheric composition, and surface temperatures shift, the responses shift as well. Weather also carries memory in subtle ways. Soil moisture affects future rainfall, snowpack influences river flow months later. Ocean temperatures shape storm intensity long after the initial heat was absorbed. These delayed effects make weather feel unpredictable, even though the processes involved are continuous. What happens today influences what is possible tomorrow, not through intention, but through stored energy and altered conditions. There is a quiet lesson in viewing weather as a whisper rather than a command. Whispers require attention to hear. They are easy to dismiss until they accumulate. Small changes in average temperature or moisture may seem insignificant in isolation, but over time they reshape patterns. A slightly warmer ocean fuels stronger storms. A slightly drier region shifts vegetation. These are not sudden decrees. They are gradual adjustments that become noticeable only when thresholds are crossed. Weather's influence on human history is extensive, even when it goes unacknowledged. Droughts have altered migration routes. Prolonged cold periods have shortened growing seasons. Favourable climates have supported population growth and trade. These influences were not deliberate acts by the planet, but they guided possibilities nonetheless. Societies flourished where conditions allowed and struggled where they did not. Even now, daily weather subtly guides behaviour. People linger outdoors on mild days and retreat when conditions turn harsh. Energy use rises and falls with temperature. Mood and productivity shift with sunlight and cloud cover. These responses are not conscious calculations most of the time. They are intuitive adjustments to environmental cues that have always mattered. Seeing weather as response rather than command can also change how it feels emotionally. Storms become less like intruders and more like expressions of imbalance resolving itself. Calm periods become temporary alignments rather than guarantees. This perspective does not remove risk or inconvenience, but it places them within a broader context of ongoing planetary adjustment. As you listen to rain or wind, or even to silence broken only by distant sounds, you're experiencing Earth in the middle of conversation with itself. Heat is moving, moisture is cycling, pressure is equalizing. You are not the focus of this process, but you are part of the environment through which it unfolds. Beneath every story humans tell about themselves, beneath borders, buildings, roads, and names, there is a layer that existed long before language and will remain long after it changes. The surface of Earth feels solid and dependable when we walk on it, but that sense of stability is only part of the truth. The ground beneath us is not a single unbroken shell. It is divided, moving, reshaping itself slowly and sometimes suddenly, carrying heat, pressure, and memory through immense spans of time. This crust, thin compared to the rest of the planet, quietly directs where life gathers, where it struggles, and where it disappears. From a human perspective, land feels permanent. Mountains seem eternal. Continents appear fixed on maps, outlined in familiar shapes that rarely change within a lifetime. Yet the crust is restless. It floats atop a deeper, hotter layer of rock, broken into plates that drift, collide, separate, and grind past one another. This movement is slow enough to be invisible day to day, but fast enough to reshape the planet over millions of years. Every valley, plateau, and ridge carries the imprint of this motion. Where plates collide, land is forced upward. Mountains rise not because Earth wants peaks, but because rock has nowhere else to go. Pressure builds until material folds and fractures, lifting stone into the sky. These mountains then influence weather patterns, catching moisture, casting rain shadows, and shaping ecosystems on either side. Human settlements respond to this without always realizing why. One side of a range becomes fertile and wet. The other grows dry and sparse. Cultures develop differently, separated by elevation as much as by distance. Where plates pull apart, new crust forms. Magma rises from below, cooling into rock as it meets the surface. This happens most dramatically along mid-ocean ridges, hidden beneath water, where new seafloor is constantly being created. On land, similar processes form rift valleys, long scars where continents slowly stretch and thin. These regions often become pathways for rivers, migration routes, or fertile zones fed by volcanic soil. Once again, the crust does not plan these outcomes. It sets conditions. Life follows. Fault lines, where plates slide past one another, create tension stored over decades or centuries. That tension is released as earthquakes, moments when the ground shifts suddenly, reminding us that stability is conditional. Cities built atop these zones often thrive despite the risk, drawn by access to water, trade routes, or fertile land created by the same geological forces that generate danger. The crust gives and takes without intent, shaping opportunity and vulnerability together. Volcanoes offer another glimpse into the crust's influence. They are not random openings, but expressions of pressure and heat escaping through weak points. Over time, volcanic activity builds islands, enriches soil, and alters atmosphere and climate. Entire civilizations have grown in the shadow of volcanoes, benefiting from fertile land while living with the possibility of eruption. When eruptions occur, they can destroy settlements in hours, yet over longer spans, they create the very conditions that attract life back again. Soil itself is a product of crustal processes interacting with weather and biology. Rock weathers into smaller particles, organic matter accumulates, minerals become available to plants. The thickness and fertility of soil vary dramatically depending on underlying geology. Regions with deep, nutrient-rich soils support agriculture and dense populations. Regions with thin or rocky soils limit growth and push societies toward different ways of living. These outcomes are often attributed to climate or culture, but the crust beneath them plays a decisive role. Rivers too owe their paths to the structure of the crust. Water flows downhill, but the shape of that downhill path is carved by fractures, folds, and varying rock hardness. Over time, rivers deepen valleys, transport sediment, and build deltas where they meet the sea. These deltas become some of the most productive and populated regions on Earth, not because humans chose them arbitrarily, but because geology and water combine to create conditions favourable to life and trade. Human history repeatedly aligns with tectonic boundaries and geological features. Trade routes follow mountain passes formed by uplift and erosion. Ports emerge where coastlines, shaped by ancient faults and rising seas, create natural harbours. Resource extraction targets regions where the crust concentrated minerals through past volcanic or tectonic activity. Even political borders often reflect geological barriers, following ridges, rivers, or deserts formed by crustal movement. What is striking is how rarely these deep influences are acknowledged in everyday narratives. Stories focus on leaders, wars, inventions, and ideas. Beneath all of that, the crust quietly constrained options. A city could rise where stone and water were accessible. A civilization could expand where land was arable. Empires stalled where mountains or seas intervened. None of this required conscious direction by the planet. It emerged from structure interacting with time. The crust also governs long-term climate through its role in carbon cycling. Mountain building exposes fresh rock to weathering, a process that removes carbon dioxide from the atmosphere. Volcanic activity releases carbon dioxide back into the air. Over millions of years, this balance influences global temperature. Ice ages and warm periods owe as much to tectonics as to orbital cycles. The ground beneath us participates in regulating the air above us, linking deep Earth to surface experience. Even the distribution of earthquakes and volcanoes, which might seem like purely geological curiosities, influences cultural memory and architecture. In regions where the ground shakes regularly and buildings are designed to flex, social practices adapt to uncertainty. In stable regions, different assumptions take hold. Risk perception itself becomes shaped by crustal behaviour, influencing how societies plan for the future. The crust is also where the planet stores much of its physical history. Layers of sediment record ancient seas, deserts, forests, and mass extinctions. Fossils preserve traces of life that responded to past conditions. These records exist not as stories written for us, but as physical consequences of processes unfolding over time. Humans learn to read them only by paying close attention to the ground beneath their feet. From the perspective of the crust, human presence is recent and light, yet noticeable. Cities add weight. Mining removes mass. Reservoirs alter pressure along faults. These changes can influence geological behaviour at local scales, sometimes triggering small earthquakes or subsidence. This does not mean humans control the crust, but it does mean the crust responds to altered conditions, continuing its role as an active participant rather than a passive platform. The idea that Earth controls everything becomes clearer here, not as dominance but as deep influence. The crust determines where water flows, where heat escapes, where nutrients accumulate, and where hazards concentrate. Life and culture adapt to these patterns, often without recognizing their source. Stories are told about success, failure, migration, and conflict, while the geological stage quietly shapes what is possible. This influence unfolds over timescales that dwarf individual lives, which makes it easy to overlook. A fault may remain locked for centuries before slipping. A mountain range may rise faster than the erosion for millions of years, then slowly wear down. Continents drift at the speed fingernails grow, yet over enough time they rearrange oceans and climates. The crust does not rush, but it does not stop. Living atop this moving surface requires a kind of trust, even if it is unconscious. Most days the ground behaves as expected. It supports weight. It stays where it is. This reliability allows attention to drift elsewhere, toward daily concerns and immediate goals. Occasionally, that trust is interrupted by earthquakes or eruptions, reminders that stability is provisional. Afterward, rebuilding often begins in the same place, because the deeper forces that made the location attractive remain. The ground beneath you may feel different, not unstable, but active in a way that is usually hidden. The floor supports you because forces are balanced at this moment. The land outside holds shape because stress has not yet exceeded resistance. This balance will shift someday, slowly or suddenly, because the crust is always adjusting to heat and gravity. And above this slow, patient movement of rock, other systems continue their faster exchanges. Heat rises, air moves, clouds form, weather responds to landscapes shaped by tectonics, while landscapes are gradually reshaped by weather. The planet's layers are not separate. They speak to one another constantly, linking deep time to daily experience. The oceans cover most of this planet, yet for much of human history they were treated as empty space, gaps between places that mattered. Maps coloured them blue and focused attention on the edges, on the land where people lived and built and named things. But the oceans are not background. They are not passive containers holding water in place. They are active systems that regulate temperature, chemistry, movement, and life on a planetary scale. Long before humans learned to cross them, the oceans were already deciding which forms of life could exist, where they could flourish, and how stable their conditions would be. To understand how oceans decide who thrives, it helps to stop thinking of them as static bodies of water and start thinking of them as engines. They absorb enormous amounts of heat from the sun, far more than land ever could. Water has a high capacity to store heat, which means it warms slowly and cools slowly. This single property has profound consequences. It smooths temperature extremes, preventing Earth from swinging wildly between scorching heat and deep cold. Coastal regions experience milder climates than inland areas at the same latitude, not by chance, but because nearby oceans release and absorb heat steadily. This thermal buffering extends far beyond coastlines. Ocean currents transport heat across the globe, redistributing energy from equatorial regions toward the poles. Warm water flows north and south, releasing heat into the atmosphere, while cooler water sinks and returns toward the equator. This circulation operates like a conveyor belt, moving vast amounts of energy quietly and continuously. Without it, large portions of the planet would become far less hospitable to life. These currents are not random. They are shaped by Earth's rotation, wind patterns, temperature differences, and the arrangement of continents. The placement of land masses directs ocean flow, channeling currents through narrow passages or allowing them to spread across open basins. As continents drift over geological time, ocean circulation changes, altering climate and influencing which regions remain habitable. Life adapts or relocates accordingly. The oceans also regulate atmospheric composition. They absorb carbon dioxide from the air, buffering changes in climate. Phytoplankton, tiny photosynthetic organisms drifting near the surface, use sunlight and dissolved nutrients to produce energy, releasing oxygen as a byproduct. These organisms contribute a significant portion of the oxygen humans breathe, even though they remain invisible to most people. Life on land depends on processes happening in open water far from shore. Nutrients play a crucial role in determining which parts of the ocean support abundant life. Regions where deep, nutrient-rich water rises to the surface, known as upwelling zones, teem with productivity. Phytoplankton bloom, supporting fish populations and complex food webs. Coastal societies near these zones have historically thrived on fishing, trade, and stable food supplies. Where upwelling is weak or absent, oceans may appear vast but remain relatively barren, limiting what life can extract from them. Salinity adds another layer of influence. The concentration of salt in seawater affects density, circulation, and the ability of organisms to survive. Species evolve to tolerate specific salinity ranges. Estuaries, where rivers meet the sea, create gradients that support unique ecosystems. These zones often become hotspots of biodiversity and human settlement, offering fertile land, fresh water, and access to marine resources. Again, the ocean's properties quietly shape opportunity. The oceans decide who thrives not only through abundance, but also through restraint. They limit growth as much as they support it. Temperature thresholds determine which species can survive in certain waters. Oxygen levels restrict how large organisms can grow and how active they can be. Changes in acidity affect shell formation and metabolic processes. When conditions shift beyond tolerable ranges, populations decline or move, sometimes rapidly. These shifts have occurred many times in Earth's history. past changes in ocean circulation and chemistry are linked to mass extinctions. When currents slowed or oxygen levels dropped, large portions of marine life vanished. These events reshaped ecosystems on land as well, demonstrating how deeply interconnected ocean systems are with the rest of the planet. Life does not get to vote on these changes. It responds, adapts, or disappears. Human societies have always been tied to the oceans, even when they believed themselves land-focused. Weather patterns that determine rainfall depend heavily on ocean temperatures. Monsoons, droughts, and storm tracks are influenced by how heat is stored and released by the sea. Agricultural success in land often traces back to conditions thousands of kilometres away in the ocean. Crops fail or flourish because of subtle shifts in water temperature far beyond the horizon. Trade routes developed along currents and prevailing winds. Early sailors learned to read ocean behaviour intuitively, adjusting routes to work with natural flows rather than against them. Ports grew where geography and currents aligned, becoming centres of commerce and culture. These developments were not purely strategic choices. They were responses to the constraints and opportunities presented by moving water. The oceans also shape risk. Storm intensity depends on sea surface temperature. Warmer waters fuel stronger storms, transferring heat upward into the atmosphere. Coastal communities benefit from proximity to the sea, but they also face hazards that inland areas do not. Flooding, erosion, and storm surge are not anomalies. They're expressions of ocean energy interacting with land. Decisions about where to live and build are often made within these boundaries, whether acknowledged or not. On longer timescales, oceans influence sea level, which in turn reshapes coastlines and habitability. During ice ages, large volumes of water are locked in ice sheets, lowering sea levels and exposing land bridges. These bridges allow migration and exchange between continents. When ice melts, sea levels rise, flooding low-lying regions and isolating populations. Human history includes repeated adjustments to these changes, from relocation to adaptation to loss. Even today, modern infrastructure remains sensitive to ocean behaviour. Shipping depends on predictable currents and manageable storms. Fisheries rely on stable ecosystems that can collapse when conditions shift. Coastal cities face rising seas as ocean temperatures increase and ice melts. These challenges are often framed as technical or political problems, but beneath them lies a fundamental reality. The ocean sets conditions, humans respond. The idea that oceans decide who thrives does not imply intention or fairness. The ocean does not reward wisdom or punish ignorance. It operates through physics and chemistry. When nutrient flows support abundance, life flourishes. When conditions deteriorate, life struggles. Human systems, despite their complexity, are not exempt from these dynamics. Technology can buffer impacts temporarily, but it cannot remove dependence. What makes the ocean's influence particularly powerful is its scale. Changes happen gradually enough to be ignored until they cross thresholds. A slight increase in average temperature may seem trivial, but it can shift species distributions, alter current strength, and change weather patterns. By the time impacts are obvious, underlying processes have often been unfolding for decades. The ocean also has inertia. Because of its size and heat capacity, once it changes, it does not quickly revert. This gives ocean-driven systems a kind of momentum that outlasts short-term interventions. Decisions made on land today interact with ocean processes that will continue responding long into the future. This is not because the ocean resists change, but because it integrates energy and material over vast volumes and long periods. There is something quietly humbling in realizing how much of life's success depends on conditions far from where it unfolds. A forest thrives because rainfall patterns remain stable. Those patterns depend on ocean temperatures. A city prospers because agriculture succeeds. That success depends on seasonal climate shaped by currents and heat exchange. Cause and effect stretch across space and time, linking everyday experience to distant waters. As you consider this, the ocean may begin to feel less like a backdrop and more like an unseen organizer. It does not manage outcomes deliberately, but it sets the stage so thoroughly that outcomes emerge within its constraints. Species evolve where temperatures allow, cultures arise where resources are reliable, trade expands where routes are navigable, collapse occurs when balance shifts too far. This perspective does not require fear or reverence, it simply invites attention. Oceans are not something humanity stands above or outside. They are systems humanity exists within. Whether acknowledged or ignored, their influence continues, steady and far-reaching. And beneath the oceans themselves lies the same restless structure discussed earlier, the crust shaping basins and ridges, directing currents and isolating seas. Above them, winds and weather respond to heat released from the surface. Nothing operates alone. The ocean is a central participant in a layered system, quietly determining which arrangements of life remain possible at any given moment, while the planet continues its slow, patient adjustment. Most of the forces that shape daily life are visible in some way. You can feel wind on your skin, you can see clouds gather, you can watch waves rise and fall. Even gravity, though invisible, announces itself through weight and motion. But one of the most influential planetary forces surrounding you right now leaves almost no trace in ordinary experience. It does not push, pull, warm or cool you directly. You cannot hear it, smell it, or feel it. And yet, without it, life on Earth as we know it would be profoundly different and likely impossible in its current form. This force is Earth's magnetic field, a vast invisible structure generated deep within the planet, extending far into space, quietly deflecting danger while shaping systems we rarely connect to it. It does not act like a wall. It does not block threats outright. It bends them, redirects them, and weakens them just enough for the atmosphere and surface to remain stable. In doing so, it creates a protected environment in which complexity can persist. To understand this magnetic shield, it helps to move inward first, toward the center of the planet. Beneath the crust and mantle lies Earth's core, divided into a solid inner core and a liquid outer core composed primarily of iron and nickel. The outer core is in constant motion. Heat from the inner core causes convection, while Earth's rotation organizes that movement into swirling patterns. Moving conductive material generates electric currents, and those currents produce a magnetic field. This process is known as the geodynamo. Nothing about this system is static. The magnetic field fluctuates, it shifts, its strength varies across the planet. Over long periods, it has even reversed direction, with north and south swapping places. These changes unfold slowly enough that life adapts, but quickly enough to leave clear signatures in geological records. Lava flows preserve the magnetic orientation present when they cooled, allowing scientists to trace the field's history stretching back millions of years. The result of this internal motion is a magnetic field that extends far beyond the atmosphere, forming a region called the magnetosphere. This region interacts with the solar wind, a continuous stream of charged particles flowing outward from the sun at high speed. Without Earth's magnetic field, these particles would strike the upper atmosphere directly, stripping it away over time much as they did on Mars, which lacks a strong global magnetic field. Instead, Earth's magnetosphere deflects most of this solar wind, forcing it to flow around the planet rather than straight into it. Some particles become trapped along magnetic field lines, spiraling toward the poles. When they collide with atmospheric gases, they produce auroras, shimmering curtains of light that serve as visible reminders of an otherwise unseen protective system. These lights are not decorations. They are evidence of ongoing interaction between Earth and space. This shielding role is central to the idea that Earth controls conditions rather than events. The magnetic field does not prevent all solar particles from reaching the atmosphere. It reduces their impact, slows their penetration, and limits their ability to erode the air we depend on. Over billions of years, this moderation has helped preserve Earth's atmosphere, allowing it to remain thick enough to support liquid water, regulate temperature, and sustain complex chemistry. Radiation is another factor quietly managed by the magnetic field. High-energy particles from the sun and beyond can damage biological tissue and disrupt molecular structures. Earth's magnetic field, combined with the atmosphere, reduces exposure at the surface. This does not mean radiation is absent, but it means levels remain within ranges life has adapted to tolerate. Remove or significantly weaken this shield, and mutation rates would rise, ecosystems would shift, and survival would become more difficult for many organisms. The influence of the magnetic field extends into navigation and behaviour. Many species, including birds, turtles, fish and insects, use Earth's magnetic field as a guide. They sense direction and position through mechanisms that are still being studied, aligning migrations across vast distances with remarkable precision. These animals do not carry maps. They respond to a planetary signal embedded in the environment itself. Human use of magnetism came much later. Compasses allowed navigation across open seas long before satellites and digital maps existed. Trade routes expanded because sailors could maintain direction even when stars were hidden or coastlines vanished over the horizon. This technological leap reshaped global history, yet it depended entirely on a force humans did not create and cannot control. The compass needle does not point north because someone told it to. It aligns with Earth's magnetic field because that field is there. Even now, modern technology remains sensitive to magnetic conditions. Satellites operate within the magnetosphere, and changes in solar activity can disrupt their function. Power grids can be affected by geomagnetic storms, as induced currents overload systems designed for calmer conditions. Communication networks, navigation systems, and even aviation routes must account for magnetic behaviour, adjusting operations when the field interacts strongly with solar events. Despite this influence, the magnetic field remains psychologically distant for most people. It does not shape daily routines in obvious ways. It does not announce seasonal change or signal immediate danger. Its work is preventative rather than corrective, reducing harm rather than responding after the fact. Because of this, it is easy to forget it exists at all, even though it surrounds everything we know. The field's variability adds another layer of quiet control. Magnetic north does not stay in one place. It drifts over time as conditions in the core change. Maps must be updated, navigation systems must be recalibrated. These shifts are gradual, but they remind us that even protective systems are dynamic. Earth does not lock itself into perfect stability. It balances, adjusts, and continues. Magnetic reversals offer a particularly striking example of this dynamism. During a reversal, the field weakens and becomes more complex before re-establishing itself in the opposite orientation. This process can take thousands of years. Geological evidence suggests that reversals have occurred many times without causing mass extinctions, but they likely altered radiation exposure and environmental conditions enough to influence evolutionary pathways. Life persisted, but under slightly different constraints. The magnetic field also interacts with Earth's interior in subtle ways. It provides indirect information about core dynamics, heat flow, and composition. Changes in the field reflect changes deep within the planet, linking surface experience to processes far below. In this way, the magnetic shield is both a protective boundary and a diagnostic tool, revealing aspects of Earth that would otherwise remain inaccessible. Thinking of the magnetic field as a shield can be misleading if it suggests rigidity. It is not a fixed barrier. It is flexible, responsive, and permeable in controlled ways. It bends under solar pressure. It stretches and compresses. It allows some particles through while deflecting others. This selective behaviour is part of what makes it effective. Total isolation would not work. Interaction must be managed, not eliminated. This management without intention mirrors other planetary systems. Weather redistributes heat, oceans move energy, gravity shapes structure, magnetism moderates interaction with space. Each system operates according to physical laws, not goals. Together, they create an environment where life can persist long enough to become complex, self-aware, and capable of wondering about its surroundings. The idea that Earth controls everything often triggers resistance because control is associated with authority and constraint. But control at this scale is not about domination. It is about setting the boundaries within which variation occurs. The magnetic field does not dictate which species evolve or which civilizations rise. It ensures that the conditions allowing evolution and civilization remain possible at all. As you sit with this, consider how different Earth would be without this invisible structure. The sky might look similar at first, but over time the atmosphere would thin, water would be lost, surface radiation would increase, the balance supporting life would erode. None of this would happen suddenly. It would unfold gradually, quietly, as protective moderation disappeared. That gradual nature is what makes planetary control so easy to overlook. Earth rarely acts in ways that feel immediate or personal. Its systems operate continuously, shaping probability rather than outcomes. The magnetic field does not save individual lives. It preserves an environment in which lives can exist in the first place. And while this shield surrounds the planet, it does not act alone. It works in concert with the atmosphere it protects, the oceans beneath, and the crust below. These layers interact, overlapping in function and influence. What is deflected above affects what settles below. What is preserved aloft allows processes at the surface to continue. It is difficult to think of soil as something that writes anything at all. It looks inert, crumbly, often ignored unless it stains clothing or fails to support what we want to grow. It sits beneath notice, treated as background rather than author, and yet soil has quietly shaped the course of human history more consistently than kings, inventions, or ideologies. Civilizations have risen where soil allowed them to, and they have declined when it no longer could support them. Long before words were carved into stone or written on paper, the ground beneath people was already determining what kind of stories could unfold. Soil is not simply dirt. It is a living interface between rock, air, water, and life. It forms slowly through the weathering of rock, the decay of organic matter, the action of microbes, roots, insects, and time. In many places, a single centimetre of fertile soil can take hundreds of years to develop. This slowness matters. It means that soil carries memory. It reflects past climates, past vegetation, past geological events. When humans arrive, they step into a process already underway, one that cannot be hurried without consequence. The composition of soil determines what can grow. Nutrients like nitrogen, phosphorus, potassium, and trace minerals must be present in usable forms. Texture matters too. Sandy soils drain quickly but struggle to hold nutrients. Clay-rich soils retain water and nutrients but can become compacted and difficult for roots to penetrate. Loam, a balance of sand, silt, and clay, tends to be most productive. These properties are not evenly distributed across the planet. They depend on underlying geology, climate, and biological history. Where soil is deep and fertile, agriculture becomes possible. Where agriculture becomes reliable, populations grow. Where populations grow, settlements expand, specialize, and eventually form complex societies. This chain is so consistent that it can feel inevitable in hindsight. River valleys with rich alluvial soils supported early civilizations, not because people preferred rivers aesthetically, but because periodic flooding replenished nutrients and maintained fertility. The land could be farmed year after year without exhausting itself, at least for a time. In contrast, regions with thin or fragile soils imposed limits. Nomadic lifestyles emerged where farming could not be sustained. Cultures adapted to herding, hunting, or seasonal movement, not because of choice alone, but because the ground did not allow permanent agriculture. These ways of life were often described later as primitive or undeveloped, yet they represented highly tuned responses to environmental constraints. Soil wrote the outline, culture filled in the details. As societies grew, their relationship with soil became more complex. Farming practices altered soil structure. Irrigation increased yields but could also lead to salinization, gradually poisoning the land. Deforestation exposed soil to erosion, washing it away faster than it could be replaced. Ploughing increased short-term productivity while disrupting long-term stability. These changes were rarely intended to cause harm. They emerged from attempts to meet immediate needs within limits that were not yet fully understood. History offers many examples of soil quietly ending stories. In Mesopotamia, intensive irrigation in a dry climate led to salt accumulation, reducing crop yields over generations. Fields that once supported abundance became barren. In parts of the Mediterranean, deforestation and overgrazing stripped hillsides of soil, leaving behind rocky landscapes still visible today. In Central America, soil exhaustion and erosion contributed to the decline of ancient cities. These were not sudden collapses. They were slow adjustments to soil no longer able to sustain the same demands. Soil also influences power and conflict. Fertile land has always been valuable. Control over it determines food supply, wealth, and stability. Borders have been drawn and redrawn around productive regions. Wars have been fought over access to arable land and water that sustains it. Even modern conflicts often trace back to land degradation, drought, and declining agricultural potential. These factors create pressure that social systems must absorb or redirect. The influence of soil extends into economics. Crops suited to certain soils become commodities. Regions specialize based on what the land supports. Trade networks develop to exchange surplus and scarcity. When soil productivity changes, economies adjust. Sometimes they diversify. Sometimes they collapse. Soil does not negotiate. It responds to inputs and conditions, and societies must align with those responses or face limits. Soil also shapes migration. When land becomes less productive, people move. This movement can be gradual or sudden, voluntary or forced. Over time, large-scale migrations have reshaped demographics, languages, and cultures. While these movements are often explained through political or social narratives, environmental constraints, including soil degradation, frequently play a quiet but decisive role. People follow opportunity, and opportunity often follows fertile ground. Beyond agriculture, soil influences infrastructure and settlement patterns. Stable soils support buildings and roads. Unstable soils shift, compact, or collapse. Cities built on floodplains or soft sediments face subsidence and damage. Engineering can mitigate some risks, but the underlying properties of soil remain influential. Decisions about where to build are constrained by what lies beneath the surface, even when that constraint is not consciously acknowledged. Soil also interacts with climate in ways that amplify its influence. It stores carbon, helping regulate atmospheric composition. Healthy soils rich in organic matter absorb carbon dioxide, moderating climate change. Degraded soils release carbon, contributing to warming. Moist soils influence local temperatures and humidity. Dry soils exacerbate heat. These feedbacks mean that soil does not merely respond to climate, it participates in shaping it. On shorter timescales, soil affects daily experience. It determines how water infiltrates, or runs off during rain, influencing floods and droughts. It affects dust levels in dry regions, impacting health and visibility. It shapes the vegetation that provides shade, food, and habitat. These factors influence comfort, productivity, and resilience in ways that feel immediate, even though they are rooted in slow processes. Modern technology has altered how societies interact with soil. but it has not removed dependence. Synthetic fertilizers can replace some nutrients temporarily, but they do not restore soil structure or microbial communities. Heavy machinery increases efficiency but can compact soil, reducing long-term productivity. Global trade allows food to be transported far from where it is grown, obscuring the connection between consumption and land. Yet the soil doing the growing still matters, regardless of where the food is eaten. There is also a cultural dimension to soil. Many traditions link identity to land, not just as territory but as substance. Stories, rituals, and practices often reflect intimate knowledge of local soils, seasons, and crops. When people are separated from their land, something more than economic security is lost. A relationship with the ground that sustained generations is disrupted. Soil carries cultural memory as much as biological potential. From a scientific perspective, soil is one of the most complex systems on Earth. A single handful can contain billions of microorganisms interacting in ways that regulate nutrient cycling, disease suppression, and plant growth. These communities respond to temperature, moisture, and management practices, alter the conditions, and the community shifts. Productivity follows. This complexity makes soil resilient to some disturbances and vulnerable to others. Thinking of soil as something that writes history does not mean imagining it as conscious or purposeful. It means recognizing that constraints shape narratives. Soil sets limits on what can be grown, how long it can be grown, and how resilient a system is to stress. Within those limits, human ingenuity operates. When limits are ignored or exceeded, consequences accumulate, often slowly enough to be dismissed until they become unavoidable. This perspective can change how progress is understood. Expansion, intensification, and growth are often celebrated without regard for soil's capacity to sustain them. When yields increase temporarily, it can feel like success. When declines follow decades later, blame is often placed elsewhere. Soil rarely gets credit for prosperity or blamed for collapse, even though it underlies both. As you consider the ground beneath you, it may feel ordinary, unremarkable, but it holds the residue of countless interactions between rock, water, air, and life. It reflects decisions made long before you arrived and will influence what remains possible long after. It does not announce its limits loudly. It reveals them gradually through productivity gained or lost, stability maintained or eroded. There are moments in Earth's history when change does not arrive gently. Conditions shift beyond familiar ranges. Temperatures climb or fall for long stretches of time. Oceans alter their chemistry. Ice advances across continents or retreats toward the poles. In those moments, life does not debate or negotiate. It responds. Sometimes that response is gradual, unfolding over thousands of generations. Other times it is abrupt, compressing loss and adaptation into spans that feel sudden even on geological timescales. When Earth adjusts, life follows, not because Earth intends to direct it, but because the rules of survival are rewritten. It is tempting to imagine life as the main actor in the story of the planet, evolving, diversifying, and shaping environments to its liking. In reality, life has always been reactive. It emerges within conditions it did not choose. It persists only as long as those conditions remain within tolerable bounds. When boundaries move, life either moves with them, adapts to new constraints, or disappears. This has happened repeatedly, long before humans existed, and will continue regardless of human awareness. Earth's adjustments come from many sources. Orbital variations alter how sunlight is distributed across the planet. Tectonic shifts rearrange continents, opening and closing ocean gateways. Volcanic activity injects gases and particles into the atmosphere, changing temperature and chemistry. Ocean circulation reorganizes as salinity and heat distribution shift. None of these processes are rare. They are part of Earth's ongoing behavior. What changes is how strongly they express themselves and how quickly their effects cascade through interconnected systems. Life responds first at the margins. Species living near the edges of their tolerance ranges feel pressure earliest. Slight changes in temperature or moisture reduce reproductive success. Food availability shifts. Predators and competitors move. Over time, populations thin or migrate. These adjustments often go unnoticed at first, blending into background variability. Only when thresholds are crossed does change become unmistakable. The fossil record preserves evidence of these responses with remarkable clarity. Entire assemblages of species vanish from certain layers, replaced by others better suited to new conditions. These transitions are not orderly handovers. They are uneven, marked by loss, experimentation, and eventual stabilization. The 5 major mass extinctions recognized by scientists represent extreme examples, moments when Earth's adjustments outpaced life's ability to respond gradually. Consider the end Permian extinction, the most severe known. Massive volcanic eruptions released enormous amounts of carbon dioxide and other gases, warming the planet and acidifying the oceans. Oxygen levels dropped. Up to 90% of marine species and a large portion of terrestrial life disappeared. The planet did not become lifeless, but it was profoundly simplified. Recovery took millions of years, during which new forms gradually filled ecological roles left vacant. These events are sometimes described as catastrophes, which they were from the perspective of the organisms that vanished. From Earth's perspective, they were transitions. Energy balances shifted, chemical cycles adjusted, life reorganized itself around new constraints. There was no restoration to a previous state. The planet moved forward, carrying scars and changes that became the foundation for what came next. Life's response to adjustment is not always extinction. Often it is innovation. New traits emerge that allow organisms to exploit altered conditions. Changes in atmospheric oxygen enabled larger, more active animals. Cooling climates favoured insulation, migration, and seasonal behaviour. Shifts in vegetation created opportunities for new feeding strategies. Evolution does not anticipate these changes. It filters variation through survival. Traits that align with new conditions persist. Others fade. This filtering process is indifferent. It does not preserve what is complex or familiar. It preserves what works. Many lineages that dominated Earth for millions of years vanished when conditions changed. Others, previously minor, expanded dramatically. Mammals, for example, remained relatively small and unobtrusive during the age of dinosaurs. When environmental upheaval eliminated many large reptiles, mammals diversified rapidly, occupying ecological spaces that suddenly opened. This was not destiny. It was opportunity created by adjustment. Even outside mass extinctions, Earth's smaller, continuous adjustments guide life's distribution. Ice ages repeatedly expanded and contracted habitats. Forests advanced and retreated. Grasslands spread where forests once stood. Species followed suitable climates, sometimes moving thousands of kilometers over generations. Genetic diversity reflects these movements, recording past expansions and contractions written into DNA. Human evolution itself unfolded within this context. Changes in climate influenced the availability of forests and open landscapes in Africa. These shifts shaped diet, mobility, and social behavior. Upright walking, tool use, and cooperation did not emerge in isolation. They responded to environments that rewarded flexibility and endurance. When conditions favored certain traits, those traits persisted. When conditions changed, different traits became advantageous. What makes Earth's influence especially powerful is that adjustments often occur unevenly. Some regions experience dramatic change while others remain relatively stable. This creates refuges where life persists and sources from which recolonization occurs later. During glacial periods, pockets of warmer habitat allowed species to survive. When ice retreated, those survivors spread outward again. Geography and timing mattered. Where you were determined whether you endured. The oceans provide clear examples of this unevenness. Changes in circulation can starve some regions of nutrients while enriching others. Oxygen-poor zones expand or contract. Coral reefs thrive when temperatures and chemistry align, then bleach and collapse when thresholds are exceeded. Marine life responds quickly because water transmits change efficiently. On land, responses can be slower but no less decisive. These patterns reveal something important about control. Earth does not micromanage life. It does not dictate outcomes. It sets conditions. When those conditions shift, life reorganizes accordingly. Control lies in the boundaries, not the details. Life has freedom within those boundaries, but that freedom is constrained by physics, chemistry, and energy availability. This relationship complicates how humans think about dominance. Modern societies often assume that technological sophistication grants immunity from environmental adjustment, yet history shows that complexity can increase vulnerability. Highly specialized systems perform well under stable conditions but struggle when variability increases. Agriculture dependent on narrow climate ranges, infrastructure built for historical sea levels, and economies reliant on predictable patterns all assume continuity that Earth does not guarantee. Life's responses to adjustment are not moral judgments. They are outcomes of alignment or misalignment. Species that adapt persist, those that cannot disappear. The planet does not mourn or celebrate these changes. It continues adjusting. From this perspective, extinction is not failure in a cosmic sense. It is resolution of a mismatch between form and environment. Understanding this can feel unsettling because it removes the comfort of permanence, but it also removes the illusion of exception. Humans are not outside this process. We are participants. Our biology, societies, and technologies operate within Earth's constraints. When those constraints change, response will be required, whether chosen or imposed. Response does not always mean collapse. Adaptation can be creative. Humans have altered practices, migrated, diversified food sources, and developed new tools in response to environmental pressure many times. What matters is recognizing that adjustment is inevitable. The question is not whether Earth will change, but how quickly and how prepared systems are to respond. Earth's adjustments are often slow enough to be ignored in the short term. That slowness can be deceptive. Gradual warming, incremental sea level rise, shifting precipitation patterns all accumulate. Because they do not feel urgent day to day, they're easy to postpone addressing. Life, however, responds to cumulative conditions, not intentions. Thresholds are crossed regardless of awareness. The past shows that once thresholds are crossed, reversal is difficult. Systems move toward new equilibria. Forests become grasslands, reefs become rubble, ice sheets retreat. These changes may stabilize eventually, but not necessarily in ways favorable to existing forms of life. Recovery, when it occurs, produces something new, not a return to what was. This does not mean Earth is hostile to life. On the contrary, it has supported life for billions of years through countless adjustments. What it does not do is prioritize any particular configuration. Diversity rises and falls, complexity waxes and wanes, stability is temporary, change is constant. As you sit with this idea, it may shift how you think about resilience. Resilience is not resistance to change, it is the capacity to respond to it. Life that persists does so by aligning with conditions rather than insisting on permanence. That lesson applies at every scale, from microbes adjusting metabolism to societies rethinking how they inhabit land. Earth's adjustments will continue, driven by forces far larger than individual decisions. Within that reality, life will keep responding, experimenting, and reorganizing. Some paths will close, others will open. None of this requires intention or awareness. It follows from the simple fact that conditions define possibility. It often feels as though humans are in control, cities expand, technologies accelerate. Landscapes are reshaped at speeds that dwarf anything earlier societies could manage. From inside this experience, it is natural to believe that humanity has taken the wheel, that we are steering Earth rather than responding to it. The language we use reflects this confidence. We talk about managing resources, engineering solutions, mastering environments, bending nature to our needs. From close up, the evidence seems convincing, yet when the view pulls back, that certainty begins to soften. For all our apparent control, human systems still operate within boundaries that we did not create and cannot suspend. We plan, but only within climates that permit agriculture. We build, but only on land that can bear weight. We travel, but only through air and water that obey physical laws. Even the most advanced technology depends on energy flows and material availability rooted in planetary systems. The question becomes less about whether humans act, and more about whether our actions truly steer outcomes, or simply follow paths already shaped by Earth. Steering implies choice among alternatives. It suggests that multiple directions are equally possible, and that intent determines which one is taken. Being steered suggests constraint, guidance, or pressure that narrows options regardless of preference. Human history contains examples of both. People innovate, adapt, and make decisions that alter trajectories. At the same time, those decisions repeatedly converge towards similar solutions when faced with similar environmental conditions, even across cultures that never interacted. Consider agriculture. Independent societies across the world developed farming at different times, yet the crops domesticated, the tools created, and the settlement patterns that followed show striking parallels. These similarities were not coordinated. They emerged because Earth presented similar opportunities and limits. Certain plants responded well to cultivation. Certain animals could be domesticated. Certain climates supported predictable harvests. Human ingenuity worked within these parameters, not outside them. When agriculture spread, it did not spread evenly. It flourished where rainfall, temperature, and soil allowed. It struggled or failed where conditions were marginal. Societies did not simply choose to farm or not farm based on preference. They responded to what the land could sustain. Even when farming was introduced into less suitable regions, it often required continuous support or eventually collapsed under pressure. The steering wheel, if there was one, was already angled by the environment. Industrialization offers another perspective. The rapid expansion of industry depended on concentrated energy sources, especially fossil fuels. These fuels were not distributed evenly. Regions with accessible coal and later oil developed differently than those without. Industrial power reshaped economies and politics, but it did so along geological lines laid down hundreds of millions of years earlier. Human decisions mattered, but they clustered around where energy was available and extractable. Climate further narrows apparent choice. Technologies that work well in temperate regions often struggle in extreme heat or cold. Infrastructure designed for historical weather patterns becomes vulnerable when those patterns shift. Energy systems depend on predictable water flow, wind patterns, and sunlight. When these inputs change, systems must adapt. Humans can redesign, relocate, or compensate, but always in response to environmental signals rather than in isolation from them. The illusion of steering is strongest when conditions are stable. During periods when climate, sea level, and resource availability change slowly, human systems can grow complex and specialized. Planning horizons extend. Confidence increases. Control feels real because constraints are not pressing. When conditions destabilize, the illusion weakens. Floods, droughts, heat waves, and crop failures remind societies that control is conditional. This does not mean human action is irrelevant. On the contrary, human responses can amplify or soften Earth's signals. Choices about land use, energy, and technology influence how strongly environmental changes are felt. Deforestation can intensify flooding. Urbanization can trap heat. Emissions can alter atmospheric composition. These actions interact with Earth systems, sometimes accelerating adjustments that would otherwise unfold more slowly. In this sense, humans participate in steering at local and intermediate scales. We influence how adjustment plays out, not whether it occurs. Earth sets the broader direction through physics and chemistry. Humans shape the texture of the path within those boundaries. This distinction matters. It suggests responsibility without granting omnipotence. There is also a feedback loop at work. As human systems grow more complex, they become more sensitive to environmental variability. Global supply chains depend on stable weather across multiple regions. Financial systems rely on predictable production and transport. Urban populations depend on continuous access to water and energy. These systems deliver efficiency and comfort, but they also reduce tolerance for disruption. Small changes can have large effects. This sensitivity can create the impression that Earth is reacting to human behaviour, steering us through consequences. In reality, Earth continues adjusting according to physical rules. Human actions alter inputs into those rules, changing outcomes. The steering is indirect. The planet does not push back, it responds. Humans then respond to that response, creating a layered dynamic that can feel like dialogue even though it is not intentional. Another factor complicates the picture further. Humans are not a single agent. They are billions of individuals and countless institutions acting with overlapping and sometimes conflicting goals. Steering implies coordination. Much of human impact emerges from aggregated behaviour rather than unified direction. No single hand turns the wheel. Outcomes arise from cumulative actions interacting with Earth systems. This aggregation makes it difficult to perceive causality clearly. Effects are delayed. Responsibility is diffuse. By the time consequences become obvious, the actions that contributed to them may be long past. Earth integrates inputs over time, smoothing signals until thresholds are crossed. Humans often interpret those thresholds as surprises, even though the underlying processes were continuous. The sense of being steered can also arise from biological constraints. Human bodies evolved under specific conditions. Temperature ranges, oxygen levels, gravity, and circadian rhythms shape cognition, health, and behaviour. Even decision-making is influenced by fatigue, stress, and environment. When heat impairs concentration or scarcity heightens conflict, behaviour shifts. These influences are subtle but pervasive, guiding outcomes without conscious intent. Culture, too, reflects environmental steering. Beliefs, values, and practices develop in response to lived conditions. Societies in resource-scarce environments often emphasise conservation and cooperation. Societies in resource-abundant environments may emphasise expansion and growth. These patterns are not deterministic, but they recur often enough to suggest underlying influence. Earth does not write laws or customs, but it shapes the conditions under which they make sense. Technology sometimes appears to break free from these patterns. Digital communication transcends distance. Climate control mitigates temperature extremes. Medicine extends lifespan beyond historical norms. Yet each of these advances rests on physical systems that remain vulnerable to planetary constraints. Data centers require cooling and electricity. Climate control requires energy. Medicine requires supply chains and stable infrastructure. The deeper dependencies remain intact. The question of steering versus being steered is therefore not binary. It is layered. Humans steer locally, temporarily, and conditionally. Earth steers globally, continuously, and impartially. The interaction between these levels produces the world we experience. When human steering aligns with Earth's constraints, systems feel resilient. When it conflicts, stress accumulates. Recognizing this interplay can change how control is understood. Control need not mean domination, it can mean alignment. Steering successfully may involve reading conditions accurately and adjusting behaviour accordingly, rather than insisting on predetermined outcomes. In this view, wisdom lies not in overpowering constraints, but in working within them with flexibility and foresight. This perspective also reframes progress. Progress measured solely by expansion and consumption ignores the context that makes such expansion possible. When that context shifts, progress defined narrowly becomes fragile. A broader view considers durability, adaptability, and compatibility with planetary systems as measures of success. Earth does not resist human ambition. It does not oppose growth or innovation. It simply continues operating according to its principles. When human systems respect those principles, outcomes tend to be more stable. When they do not, adjustment follows, not as retribution, but as consequence. As you reflect on whether humans are steering or being steered, it may become clear that the distinction itself is less important than understanding the relationship. Humans are participants in a system that predates them and will outlast them. Agency exists, but it is bounded. Choice matters, but it operates within constraints that cannot be negotiated away. This realization does not diminish human significance, it situates it. It places creativity, responsibility, and decision-making within a larger framework that gives them meaning. Steering without awareness of the terrain leads to instability. Steering with attention to underlying forces increases the chance of continuity. The sense of mastery is one of the most comfortable ideas humans carry. It suggests that problems can be solved once and for all, that systems can be optimized permanently, that enough knowledge and technology will eventually place the world on predictable rails. Mastery feels like security. It promises that uncertainty can be reduced to manageable risk, and that nature, once understood, will behave as expected. This belief has deep roots, reinforced by centuries of success in engineering, medicine, and science. Yet beneath that confidence lies something far more fragile, because mastery, as it is often imagined, depends on the assumption that underlying conditions will remain stable. Human mastery usually reveals itself through structure. Cities rise with precise grids and layered infrastructure. Machines perform tasks once limited by muscle or distance. Environments are modified to suit preference rather than tolerance. Crops grow where they did not before. Rivers are redirected. Temperature is regulated indoors regardless of season. From the inside, these achievements feel decisive, even final. They suggest that Earth has been subdued into a predictable partner. But mastery is not the same as independence. Every structure that projects control relies on continuous input. Power must flow. Materials must be extracted. Waste must be absorbed somewhere else. These dependencies are often hidden from daily experience, pushed to the margins of awareness by distance or abstraction. As long as inputs remain reliable, mastery feels real. When they falter, its provisional nature becomes clear. Consider something as ordinary as electricity. Lights turn on instantly. Devices charge silently. Climate control responds at the push of a button. This ease creates the impression of command. Yet electricity depends on fuel sources, weather conditions, water availability, grid stability, and physical infrastructure spread across vast areas. A heat wave, drought, storm, or seismic event can disrupt supply, not because technology failed intellectually, but because it encountered limits imposed by the environment it operates within. The illusion of mastery is strengthened by scale. Large systems can absorb small disturbances without obvious effect. A city may withstand a single storm, a brief outage, or a temporary shortage. This resilience reinforces confidence. But large systems are also tightly coupled. When disturbances exceed certain thresholds or cascade across interconnected networks, recovery becomes more difficult. The same complexity that enables efficiency reduces flexibility. Modern agriculture offers a clear example. Industrial farming has dramatically increased yields through mechanization, chemical inputs, and genetic selection. Food appears abundant, consistent, and controllable. Yet this system relies heavily on stable climate, predictable seasons, fertile soil, water availability and energy inputs. When droughts intensify, soils degrade, or fuel prices fluctuate, vulnerability becomes visible. Mastery here is conditional, maintained through constant intervention rather than inherent stability. Technology also creates distance between cause and effect. Resources are extracted far from where they are consumed. Waste is exported beyond sight. Environmental signals are delayed. This distance allows mastery to feel clean and detached, even when impacts accumulate elsewhere. By the time consequences return in the form of degraded ecosystems or altered climate patterns, they appear disconnected from the original actions. Another aspect of the illusion lies in control over time. Human planning often assumes linear progress. Solutions are implemented with the expectation that they will function indefinitely or improve with refinement. Earth's systems do not operate linearly. They involve thresholds, feedback loops, and delayed responses. Actions that appear beneficial in the short term can produce instability later. Because those later effects unfold slowly, they're easy to dismiss until they become unavoidable. Mastery also depends on predictability. Models, forecasts, and standards assume that past behavior provides reliable guidance for the future. This assumption works well when systems are stable. As conditions shift, predictive power weakens. Extreme events fall outside historical ranges. Infrastructure designed for average conditions faces stress from new extremes. The illusion persists because adjustments lag behind reality, not because mastery has been achieved. Psychologically, mastery offers comfort against uncertainty. It reassures individuals and societies that effort leads to control, that problems yield to intelligence. This belief is not entirely false. Human ingenuity has solved many challenges and reduced suffering in meaningful ways. The illusion arises when success is generalized beyond its domain, when local control is mistaken for global dominance. Earth systems do not invalidate human skill. They contextualize it. Engineering works because materials behave consistently within known ranges. Medicine works because biological processes respond predictably under controlled conditions. These successes occur within constraints that remain largely unchanged. When constraints shift, mastery must be renegotiated. The illusion becomes particularly strong during periods of relative environmental calm. When climate variability is low and resources are abundant, societies build assumptions into their systems. Growth becomes the default expectation. Stability is treated as normal. Planning horizons extend. Risks feel theoretical. This is when mastery narratives flourish, reinforced by prosperity and technological acceleration. History shows that these periods are often followed by adjustment. Droughts expose water dependence. Floods reveal assumptions embedded in infrastructure placement. Heat waves strain energy systems. Soil degradation undermines food security. These events are frequently described as failures of planning or governance, but they are better understood as mismatches between system design and changing conditions. One reason the illusion persists is that mastery is often framed as cumulative. Each innovation builds on the last, creating a sense of upward trajectory. Earth's influence, by contrast, feels static because it operates continuously. Gravity does not announce itself. Seasons repeat. Oceans circulate. Because these processes are always present, they fade into the background. Control appears to grow because constraints are constant, not because they have disappeared. The illusion is further reinforced by specialization. As knowledge becomes more fragmented, individuals understand parts of systems deeply, but lose sight of the whole. Expertise increases, but holistic awareness diminishes. This allows mastery to feel localized and complete within domains, while systemic vulnerability grows unnoticed. When disruptions occur, they seem surprising because no single perspective captured the full dependency network. Even language contributes to the illusion. terms like resource management and environmental control imply directionality. They suggest that Earth is an object acted upon rather than a system interacting with inputs. This framing shapes decision-making, encouraging optimization over resilience, efficiency over redundancy. It works until conditions change enough to expose brittleness. There is also a generational aspect. Each generation inherits systems built under previous conditions and assumes their stability. Adjustments unfold slowly, often beyond the timescale of political cycles or individual careers. Responsibility becomes diffuse. Mastery persists as a belief because accountability for long-term outcomes is hard to assign. When mastery fails, responses often focus on restoring control rather than re-examining assumptions. More technology, more infrastructure, more intervention are proposed. Sometimes these responses succeed, sometimes they deepen dependency. The pattern repeats because the underlying relationship with Earth's constraints remains unchanged. Recognizing the illusion of mastery does not require rejecting progress or innovation. It requires redefining what mastery means. Instead of domination, mastery could be understood as skillful participation. Instead of permanence, it could emphasize adaptability. Instead of certainty, it could value responsiveness. In this reframing, mastery is not measured by how much control is exerted, but by how well systems adjust to change without catastrophic failure. Redundancy becomes a strength rather than inefficiency. Diversity becomes insurance rather than excess. Flexibility becomes as important as precision. Earth's role in this reframing becomes clearer. The planet does not oppose human systems, it provides feedback. When systems align with constraints, feedback is mild. When they diverge, feedback intensifies. This is not moral correction, it is physical response. The illusion lies in interpreting mild feedback as permission to proceed indefinitely. As this illusion thins, a quieter understanding takes its place. Control is temporary. Stability is negotiated continuously. Mastery is not a destination but a process, one that must be revisited as conditions evolve. Earth remains an active participant in this negotiation, setting boundaries that cannot be ignored. This understanding can feel unsettling because it removes the promise of final solutions, yet it can also feel grounding. It aligns expectation with reality. It allows planning that anticipates change rather than denying it. It opens space for humility without surrender. Earth does not remember in the way humans do. It does not recall moments, replay images, or feel nostalgia for what has passed. And yet, nothing that happens on this planet truly disappears. Every event leaves a trace, sometimes obvious, sometimes buried, sometimes altered beyond easy recognition, but always present in some form. The planet carries these traces forward, layering them, compressing them, and integrating them into the ongoing structure of the world. In that sense, Earth remembers everything, not as story, but as consequence. Memory, at its most basic level, is persistence. It is the ability of a system to carry information from the past into the present. Earth does this constantly. Rock layers record ancient environments. Ice preserves atmospheric chemistry. Oceans store heat from decades ago. Soils reflect past vegetation and land use. Even the composition of the air holds signatures of earlier conditions. The planet does not reset between eras. It accumulates. Sedimentary rock offers one of the clearest examples. Layer by layer, particles settle, compact and harden, forming a vertical archive of time. Each layer reflects conditions at the moment it formed. Grain size tells stories of water speed and energy. Chemical composition reveals oxygen levels, temperature, and biological activity. Fossils capture shapes of organisms that no longer exist, preserved not because Earth intended to keep them, but because circumstances allowed it. These layers do not blur together. They stack, one atop another, creating a physical timeline that can be read millions of years later. Ice does something similar, though more delicately. In polar regions and high mountains, snow falls year after year, compressing into ice that traps tiny bubbles of air. Those bubbles are samples of ancient atmospheres, sealed away and carried forward through time. Scientists drill into these ice sheets and extract cylinders that function like vertical calendars. By analysing the gases inside, it becomes possible to see how carbon dioxide, methane and temperature changed over hundreds of thousands of years. Earth kept these records without effort, simply by allowing snow to fall and remain. Soil remembers too, though its memory is often disturbed. Layers of soil can reveal past floods, fires, farming practices, and vegetation. Charcoal fragments mark ancient burns. Pollen grains identify plant communities long gone. Chemical imbalances reflect centuries of cultivation or contamination. Even when land is ploughed or paved, deeper layers retain information about what once grew there. Memory persists beneath attempts to overwrite it. The oceans, vast and mobile, might seem less capable of memory, yet they store heat and carbon on timescales that exceed human lifespans. Water masses formed under specific conditions sink and travel slowly through the deep ocean, carrying temperature and chemical signatures across centuries. Changes introduced at the surface today may not fully circulate and reveal their consequences for generations. The ocean integrates slowly, but once it absorbs change, it does not release it quickly. The atmosphere too carries memory, though it appears fleeting. Greenhouse gases accumulate over time, altering how heat is retained. Aerosols reflect or absorb sunlight depending on their composition. Even after emissions stop, their effects linger because the system responds to totals, not moments. Air mixes rapidly, but its chemistry evolves based on what has been added and removed over long periods. The present atmosphere is a product of everything that came before it. Earth's memory is not selective. It does not preserve what is meaningful to humans and discard the rest. It keeps what physics allows to persist. This means that some events leave strong signatures while others fade quickly. A volcanic eruption deposits ash that can be traced across continents. A city built of stone leaves ruins that last millennia. A conversation vanishes almost instantly. Yet even that conversation involved energy use, breath, sound waves, and heat, all of which entered the environment and were absorbed somewhere. This persistence challenges the idea that actions can be isolated in time. Human systems often operate as though consequences end when attention moves on. Waste is disposed of. Emissions disperse. Landscapes are altered and then forgotten. Earth does not forget. Materials remain in circulation. Alterations influence future processes. The planet integrates everything into its ongoing adjustment. Nuclear fallout offers a stark example. Radioactive elements released decades ago are still detectable in soils, sediments, and organisms. They mark a specific moment in human history, embedded permanently in geological records. Long after political contexts fade, those signatures will remain, readable to any future observer capable of interpreting them. Earth did not object to their presence. It absorbed them, as it absorbs everything else. Plastics provide another illustration. Designed for durability, they persist far beyond their intended use. They fragment into smaller pieces, enter soils and oceans, and become part of sediment layers forming today. Future rock strata will contain traces of this material, a distinct marker of a particular era. This is not a moral statement. It is a physical outcome of material properties interacting with time. Earth's memory also operates through feedback. Past conditions influence future behaviour. A landscape eroded once becomes more vulnerable to erosion again. A forest cleared may alter local climate, affecting regrowth. A glacier that retreats exposes darker surfaces, increasing heat absorption and accelerating further melting. These processes mean that history is not passive. It shapes trajectories. Even biological systems carry planetary memory. Genetic diversity reflects past population sizes, migrations, and bottlenecks. Species distributions encode previous climate shifts. Ecosystems carry legacies of disturbance in their structure and composition. Life remembers Earth's past conditions because it was shaped by them. Human bodies carry this memory too. The minerals in bones were once part of ancient rock. The water in cells has cycled through oceans and clouds countless times. The oxygen in blood was released by plants responding to conditions that existed long before any human ancestor. In this sense, memory is not external. It flows through living systems continuously. What makes Earth's memory different from human memory is that it does not prioritize relevance. Humans forget selectively. We emphasize certain narratives and suppress others. Earth keeps everything it can. There is no archive limit, no deletion function. Over time, compression and transformation occur, but erasure is rare. Matter changes form, energy dissipates, but traces remain. This has implications for the idea of control. If nothing disappears, then actions accumulate. Systems evolve not just based on current inputs, but on the sum of past ones. Short-term thinking becomes misaligned with long-term reality. Decisions made for immediate benefit continue influencing conditions long after their context has changed. Earth's memory also resists revision. You cannot undo a mass extinction. You cannot easily restore a melted ice sheet or reassemble eroded soil. You can influence future trajectories, but the past remains embedded in the present. This does not mean change is impossible. It means change builds on what already exists. There is something quietly stabilizing about this perspective. It removes the pressure to control outcomes perfectly. It acknowledges that we are always acting within a story, already in progress. The planet's memory sets the opening conditions for every moment. We contribute new lines, but we do not rewrite earlier chapters. At the same time, this persistence adds weight to action. If Earth remembers everything, then nothing is truly temporary. Convenience does not erase consequence. Distance does not dissolve impact. The planet carries forward what passes through it, regardless of intent. Understanding Earth as a system that remembers everything shifts how responsibility feels. Responsibility becomes less about blame and more about awareness of continuity. What is done now becomes part of the conditions others will respond to later. Memory links generations without consent or communication. This does not require guilt or fear. It invites attentiveness. When you realize that systems retain traces, you begin to see actions as contributions rather than isolated events. The scale of contribution varies, but the principle remains. Earth integrates. And yet, despite this vast memory, Earth is not static. It does not freeze history in place, it transforms it. Layers are buried, uplifted, exposed, eroded, and recycled. Old rocks become new sediments. Carbon cycles through air, water, and life. Memory persists, but it is dynamic, continually reshaped by ongoing processes. This transformation prevents memory from becoming paralysis. The past influences the present, but it does not lock it. Change remains possible because memory is incorporated, not replayed. Earth does not relive events. It carries their effects forward into new configurations. The present moment may feel slightly heavier, but also more connected. You're not floating above history. You're embedded within it. The surface beneath you holds traces of ancient seas, forests, fires, and lives. The air around you contains molecules that have passed through countless organisms. Nothing about this moment stands alone. If Earth truly runs the system, then control looks very different from how it is usually imagined. It does not resemble leadership, command, or decision-making. It does not involve intention, preference, or awareness. Instead, it operates as a framework so deep and so consistent that everything else must align with it in order to exist at all. Running the system, in this sense, means setting the conditions under which all processes unfold, not directing the details of those processes once they begin. This idea can feel uncomfortable because it challenges the way agency is usually framed. Humans tend to think in terms of actors and actions, causes and effects that can be traced to deliberate choices. Earth does not fit neatly into that structure. It does not act in response to goals. It does not evaluate outcomes. And yet, it determines which outcomes are possible and which never arise in the first place. That kind of influence is subtle enough to be overlooked, but powerful enough to shape everything. To imagine Earth running the system, start by stripping away human-centered assumptions. Remove the idea that systems exist to serve purposes. Replace it with the idea that systems exist because conditions allow them to persist. Rivers flow not to reach the sea, but because gravity and terrain make it so. Forests grow not to provide oxygen or beauty, but because light, water, soil and temperature align in a way that supports that form of life. Humans build societies not because Earth permits them, but because Earth does not prevent them under current conditions. In this view, Earth is not an overseer. It is a constraint generator. It defines ranges, temperature ranges, pressure ranges, chemical ranges, energy availability. Everything that happens must occur within those ranges or not at all. Life evolves to occupy niches within them. Cultures develop practices that function within them. Technologies exploit regularities within them. None of this requires Earth to notice or respond deliberately. Running the system also means integrating feedback continuously. When conditions shift, processes adjust. If heat accumulates, circulation patterns change. If water availability alters, vegetation shifts. If atmospheric composition changes, temperature follows. These feedbacks do not aim for comfort or stability as humans define them. They aim for balance in physical terms, often producing states that feel extreme or disruptive to living systems adapted to previous conditions. This is where the idea of control becomes misleading. Control suggests dominance and enforcement. Earth does neither. It does not force adaptation. It simply alters the background against which adaptation occurs. Life responds because it must, not because it is instructed to. Species migrate, evolve, or vanish. Societies reorganize, relocate, or collapse. These are responses to altered constraints, not punishments or corrections. If Earth runs the system, then predictability is always provisional. Patterns exist, but they are not guarantees. Climate zones persist for long periods, but they are not fixed forever. Sea levels stabilize, then rise or fall. Ice accumulates, then melts. The system is dynamic, not chaotic, but not static either. Stability emerges temporarily when opposing forces balance. When that balance shifts, stability dissolves, and a new configuration emerges. This perspective reframes risk. Risk is not a deviation from normal behaviour. It is an expression of the system's capacity to change. Extreme events are not anomalies in a broken system. They are outcomes that become more likely under certain configurations. When heat, moisture and energy align in specific ways, storms intensify. When pressure builds along faults, earthquakes occur. The system does not malfunction. It operates according to its parameters. Human planning often assumes that the future will resemble the recent past. This assumption works when conditions change slowly. When change accelerates, the assumption fails. If Earth runs the system, then planning must account for variability as a feature, not a flaw. Flexibility becomes more valuable than optimization. Redundancy becomes more valuable than efficiency. These priorities often conflict with modern economic and technological goals, which are designed around stability. Understanding Earth as the system runner also changes how scale is perceived. Individual actions matter less in isolation and more in accumulation. A single emission does little. Trillions alter atmospheric composition. A single tree cut does not destabilize a watershed. Widespread deforestation does. Earth responds to totals and gradients, not intentions. This means that moral framing alone is insufficient to predict outcomes. Physical thresholds determine response. Time plays a crucial role here. Earth integrates change slowly. This integration creates delays between cause and effect that complicate human decision-making. Consequences may appear long after actions occur, separated by generations. When feedback finally becomes visible, the system may already be moving toward a new equilibrium. Attempts to reverse course can be difficult because momentum has built. This delayed response is not a flaw. It is a property of large systems. Oceans absorb heat slowly and release it slowly. Ice sheets melt over decades or centuries. Soil forms over centuries and erodes rapidly when disturbed. These asymmetries shape outcomes. Rapid exploitation followed by slow recovery is common because accumulation happens faster than regeneration. Earth runs the system according to these rates, not according to human timelines. If Earth truly runs the system, then progress cannot be measured solely by output or growth. It must be evaluated in terms of alignment with constraints. Systems that appear successful in the short term may be unstable in the long term if they rely on conditions that are changing. Conversely, systems that appear inefficient may persist because they tolerate variability better. Durability becomes a key metric. This does not mean Earth favours simplicity or stagnation. Complexity arises naturally where energy flows allow it. Tropical ecosystems are among the most complex on the planet because conditions support high productivity and diversity. Human societies have become complex where resources and stability permitted. Complexity is not discouraged, it is constrained. When constraints tighten, complexity must either reorganize or simplify. Running the system also means that Earth does not privilege outcomes that humans value. Biodiversity rises and falls, complexity increases and collapses, intelligence emerges and may disappear. None of these outcomes are selected for by the planet. They are side effects of conditions that support certain processes over others. This can feel unsettling because it removes the sense that progress is guaranteed or that meaning is embedded in outcomes. At the same time, this neutrality creates opportunity. Because Earth does not aim, life is free to experiment within constraints. Novel forms arise. Unexpected adaptations succeed. Human creativity exists because conditions allow it, not because it was intended. Running the system does not mean scripting outcomes. It means providing a stage where outcomes can emerge. Seeing Earth this way also clarifies responsibility. Responsibility does not mean controlling the planet. It means understanding how actions alter constraints. When human systems change atmospheric composition, land cover or water cycles, they modify the background conditions that future processes will respond to. Earth will integrate those modifications regardless of intent. Responsibility lies in anticipating integration, not in assuming exemption. This shifts ethical focus from domination to participation. Instead of asking how to control Earth, the more relevant question becomes how to operate within its systems without destabilizing the conditions that support continuity. This does not require perfection. It requires awareness of limits and feedback. If Earth runs the system, then collapse is not failure in a moral sense. It is reorganization after misalignment. Civilizations that exhaust soils, deplete water, or destabilize climates are not punished. They encounter constraints they can no longer navigate. New systems arise from what remains. This pattern has repeated many times in Earth's history, long before humans existed. This perspective also softens the fear of finality. No configuration lasts forever, but neither does loss eliminate possibility. Earth continues adjusting. Life continues responding. Even mass extinctions are followed by diversification. The system does not aim to preserve specific forms, but it does maintain the conditions under which form itself can re-emerge. Thinking this way can feel impersonal, even cold. But it also removes the burden of exceptionalism. Humans are not singled out for success or failure. We are participants in the same dynamics that shape everything else. Our intelligence allows us to perceive these dynamics, but perception does not grant exemption. If Earth truly runs the system, then listening becomes more important than commanding. Observation becomes as valuable as invention. Adaptation becomes as important as expansion. These priorities do not reject technology or progress, they contextualize them. As this idea settles, the world may feel less like something to be managed and more like something to be understood. Not understood in the sense of complete comprehension, but in the sense of relationship. Earth is not an adversary or a tool. It is the framework within which all tools function. There is something quietly reassuring about realizing that you are being held even when you're not thinking about it. Not held by intention or care in the human sense, but by structure, balance, and consistency. The ground beneath you is doing its work without effort. Gravity is steady. Air pressure remains within a narrow range that allows each breath to arrive without struggle. Temperature, while it fluctuates, stays within limits that bodies can tolerate most of the time. None of this requires your attention, and that is precisely why it can feel restful once you notice it. Resting on a world that holds us does not mean that the world is gentle in every moment. Storms still form, heat still builds, the ground still shifts. But even those changes occur within a framework that has supported life for billions of years. The same planet that produces disruption also provides continuity. The same systems that impose limits also make existence possible. Holding in this sense is not comfort alone, it is reliability. Think about how rarely you consciously register the fact that the ground will still be there when you wake up. Floors feel solid, streets support weight, hills do not suddenly dissolve beneath your feet. This expectation is so deeply ingrained that its absence is almost unimaginable. When earthquakes occur, the shock is not only physical, it is existential. Something assumed to be absolute reveals itself as conditional. And yet, even then, the ground does not disappear. It adjusts, it settles, it finds a new balance. This pattern repeats across scales. Oceans rise and fall, but they remain contained by gravity and basin shape. Atmospheres thicken or thin, but they remain bound to the planet. Climates shift, but energy continues to flow, driving weather and circulation. Life persists by adjusting to these changes, not by escaping them. The world holds not by freezing conditions in place, but by maintaining a system in which change does not dissolve everything at once. There is a tendency to associate rest with stillness, as if calm requires the absence of motion. Earth offers a different model. It is never still. Plates drift, water circulates, air moves, magnetic fields fluctuate. Yet within that motion, patterns endure. Stability emerges from activity rather than from its absence. Rest becomes possible not because nothing is happening, but because what is happening remains within tolerable bounds. Your body mirrors this. Even at rest, your heart beats, your lungs move, cells exchange chemicals, heat is regulated. Conscious rest does not stop these processes. It allows them to continue without interference. The world does something similar. It does not pause its systems to accommodate life. Life rests because those systems operate reliably enough to be trusted. This trust is mostly unconscious. You do not verify gravity before standing. You do not test oxygen levels before breathing. You do not check magnetic shielding before stepping outside. The world has proven consistent enough that these checks are unnecessary. That consistency is not guaranteed forever, but it has been reliable long enough to shape expectation. Resting on a world that holds us also means accepting limits. You cannot float indefinitely without support. You cannot survive without air, water, and moderate temperatures. These constraints are sometimes framed as restrictions, but they are also guides. They define the narrow corridor within which complexity can exist. Without them, life would not be freer. It would be impossible. Modern life often blurs this relationship. Artificial environments extend comfort beyond natural limits. Buildings insulate against heat and cold. Lights override darkness. Machines reduce physical effort. These interventions can be beneficial, even life-saving. But they can also distance awareness from underlying support systems. When comfort is constant, it becomes easier to forget what enables it. Forgetting does not remove dependence, it only delays recognition. When energy fails, when water is scarce, when air quality degrades, the connection becomes immediate again. Rest turns into effort. Stability feels fragile. These moments reveal how much support was being provided quietly all along. There is no need to romanticize this dependence. The planet does not cradle individuals, it does not prioritize ease, it simply operates. Holding emerges as a byproduct of balance rather than care. And yet, for those living within it, the effect can still feel grounding. You're here because conditions allow you to be. That allowance persists moment to moment. This perspective can soften the pressure to control everything. If the world already provides a framework that supports existence, then not every outcome requires intervention. Some processes unfold best when left within their natural bounds. Rest, in this sense, is not withdrawal, it is alignment. It is recognizing when effort is needed and when it is not. Even anxiety changes shape under this view. Many worries revolve around uncertainty and loss of control. Earth does not eliminate uncertainty. It embeds it within patterns. Weather varies, but seasons repeat. Change occurs, but not all at once. Loss happens, but renewal follows. This does not guarantee favourable outcomes for individuals, but it provides continuity for the system as a whole. Resting on a world that holds us also means recognising that support is shared. The same gravity that holds you holds everyone else. The same atmosphere circulates through countless lungs. The same oceans regulate climate for every coastline. This shared dependence connects lives without requiring coordination. Everyone participates, whether they acknowledge it or not. This connection does not demand harmony. Conflict, competition, and difference still exist, but they unfold within a common physical context. No one escapes the basic conditions. No one operates entirely independently. This shared grounding can be humbling, but it can also be calming. It reduces the sense of isolation that comes from imagining oneself alone against an unpredictable universe. When you lie down, sit quietly, or simply pause, your body makes contact with a surface shaped by geological processes older than memory. The materials beneath you were formed under pressures and temperatures far removed from human experience. Over time, they cooled, fractured, eroded, and reassembled into the ground that now feels ordinary. That ordinariness is not trivial. It is the result of extraordinary spans of adjustment settling into something usable. Even now, beneath that surface, heat moves slowly outward. Rock deforms imperceptibly. Minerals migrate. None of this disrupts your rest. It supports it indirectly by maintaining a planet that does not tear itself apart. The energy that drives this motion also powers magnetic shielding, tectonics, and long-term climate regulation. Holding happens through motion, not despite it. This understanding does not require gratitude in a sentimental sense. The planet does not need appreciation, but awareness can change how rest feels. Instead of rest being a temporary escape from effort, it can become recognition of ongoing support. You are not pausing against a void. You are pausing within a system that continues to function whether you attend to it or not. This can ease the urge to rush. Earth does not hurry. Its processes unfold over timescales that dwarf individual urgency. While human schedules demand speed, the underlying system remains patient. Aligning even briefly with that patience can feel relieving. Breathing slows, muscles release, attention widens. There is also comfort in knowing that rest does not halt contribution. Even at rest, you are part of cycles. You exhale carbon dioxide that plants use. You release heat that dissipates into air. You occupy space that redistributes pressure. These are not tasks. They are consequences of being alive within a physical system. Nothing about this moment needs to be completed. There is no conclusion required. The planet does not conclude its processes. It continues. Likewise, your experience does not need resolution. It can remain open, supported by forces that do not demand acknowledgement. As awareness settles into this broader context, the idea of Earth controlling everything no longer feels oppressive or grand. It feels quiet and structural. The planet does not direct your thoughts or choices, but it provides the stage on which thinking and choosing are possible. That stage remains whether you engage with it actively or simply rest upon it. And so, in this moment, wherever you are listening from, whatever time it is in your corner of the world, the same forces are at work. Gravity holds, air circulates, the ground supports, heat moves, none of it pauses, none of it rushes. You're free to rest within that continuity, knowing that the world beneath you is doing what it has always done, adjusting, balancing and holding.